Good evening, everyone. So today the third seminar in this seminar series, the chemistry seminar, and we have completed biology and physics seminar. And today you are going to revise all the lessons of both 10 and 11 syllabus of your oral exam. You are getting basically from grade 10 20 lessons and grade 11 15 lessons, altogether 35 lessons. Out of them you get nearly 1/3 from chemistry. And when we consider the oral science paper, you are getting every year out of 40 MCQs from around 12 to 13 chemistry MCQs. And structured essay question number, there are 4 compulsory questions, and structured essay question number 6, structured essay question number 3 from chemistry, 1 and 2 from biology, structured essay question number 3, and essay type question number 6, chemistry completely. Question number 8 and 9, part of that question number 9A also chemistry. So basically structured essay 1 complete question chemistry, structured essay question number 3 chemistry completely, and essay type question number 6 completely chemistry, and question number 9A also from chemistry. So to go for A pass or B, you have to study all the chemistry lessons 10 and 11 syllabus, because nearly 30 to 34 marks you are getting from chemistry syllabus. And without wasting much time, let me introduce today the guest lecturer of this chemistry seminar. She is Miss Madhu Haputantri. She is a A-level English medium chemistry lecturer, and last year oral batch also she conducted the chemistry seminar, and she is actually the teacher of the most of my past students, the A-level chemistry teacher, and she will guide you today, and you can get the maximum out of her to improve your chemistry knowledge. And this seminar will definitely help to you improve your chemistry marks. When we consider the last few years oral marking, many students, they have lost marks mostly from chemistry section than even from physics. Those who are going for A pass, even their chemistry part, the performance bit weaker than biology and physics. Therefore, especially grade 11 chemistry, electrochemistry, hydrocarbons, and heat changes associated with the chemical reactions, exothermic, endothermic reactions, and some industrial chemistry part, salt extraction, salt industry, sodium extraction, iron extraction. You can get essay type questions in the oral science paper. Even some distillation, the separation techniques, fractional distillation, steam distillation, chromatography. So now today the paper, you have already got the paper to your WhatsApp group, WhatsApp seminar group, and so Miss Madhu will guide you how to improve by considering all these areas. She has prepared the paper. So without wasting much time, I would like to invite today's the guest lecturer, Miss Madhu Haputantri, to continue the seminar. Thank you.
Right. Thank you, sir. Good evening, all of you. So I hope all of you have got the paper, and probably some of you might have made the printouts even. Are you ready with the hard copy, or you all are referring to the soft copy? Can I know that one first of all? Quickly drop a message to me. Right, most of you have got the hard copy, it seems, no? All right, soft copy is also there. Right. Never mind, children, I will share the PDF to you. All right, I will share the PDF to you and I will annotate everything on that one. And before I begin the discussion, just want to let you know if there's any question that you all are coming across as I proceed, without any hesitation, through the chat, you can forward the question to me. So considering an appropriate time, I will be answering all the questions. Right, so then shall we start? All of you are ready? Then the ones who have made the hard copy, you can write the answers on the paper itself. The ones who are dealing with the soft copy, I suggest you, if it is possible, correct some A4 papers or maybe some full caps. So then you can write the answers, and especially the explanations I'm giving you. So then when you are getting close to your exams, you can quickly run through the questions as well as through the explanations. Can you all confirm whether the screen is clear enough? Can everyone see this properly? Yes, nay? Right. So this is how I will be doing this. For the small questions, I will be answering the question right on the PDF itself. And when it comes to the questions where I have to give you a lot of explanations, I will be switching to the whiteboard and writing the explanations there. Okay. So then get ready with the paper, and if you are comfortable with the pen, you can go with the pen, if not a pencil. Those are very regular stuff. Then we'll start from the first one. So first question is telling which of the following has only ionic bonds. So when it comes to this question, there's a certain special word that you should be paying attention to. I'm asking for the ionic bonds. That is true, but there's a special concern, right? Special concern is there. You have to select the compound which is having only ionic bonds. So therefore, especially in the exam, when you all are dealing with the MCQ questions, definitely keep a certain habit that you are underlining or circling the important words. Otherwise, by the time you read the question and you go to the answers, sometimes you might forget the important, if not the keyword in the question. So therefore, with this one, we will do a small practice on that one as well. Right. So when you take ammonium chloride is consisting of both ionic and covalent bonds. Why do I say so? In ammonium chloride, you have ammonium, right? And you have Cl minus. Can all of you see the stuff I'm writing in this margin? Is that clear enough? Yes, nay? Right. Okay. So then ammonium chloride is consisting of ammonium and chloride. So ammonium is a cation, chloride is the anion here. Between the cation and the anion, you have the ionic bond. Then where do you get the covalent bond? If you go into the ammonium ion, right? So nitrogen is getting connected to 4 hydrogens. And the positive charge is there on nitrogen. So these bonds, the bonds that nitrogen is forming with hydrogen, those bonds are covalent, right? So then ammonium chloride, take care, it's having covalent bonds and ionic bonds, both of them are there. So we cannot take ammonium chloride as the answer for the question, because I'm particularly asking for a certain compound which is containing just, right, just ionic bonds. And then when you take water, water is having only covalent bonds. And there are 2 lone pairs on oxygen like this. These 2 bonds, OH, OH, they are covalent bonds. So then water is out because it is having only covalent bonds. Especially when it comes to the MCQ questions, when some answer is wrong, you have to definitely know what is the reason behind that. Right now, this is a practice session. So don't just chase behind the correct answer. take the maximum benefit to understand if something is wrong, what is the reason for it to become wrong. All right. So that is the biggest lesson you can learn from this. So if you know, now when it comes to any MCQ, you have 4 choices in O levels, only one is correct. So always question why this one is wrong, why this one is wrong, why this one is wrong. So when you question on the wrong answers like that, you can learn a whole lot, right? So therefore, for all the wrong answers, I will be giving the explanations. Again and again, I'm reminding you, take down the explanations, right? Because that is what is important when it comes to the last moment. Right, calcium carbonate. Calcium carbonate is also having both covalent bonds and ionic bonds. Calcium is the cation, carbonate is the anion. Again, between cation and anion, you have the ionic bonds. Inside carbonate, right? Carbonate is like this. So these carbon-oxygen double bonds and the single bonds, they are covalent bonds. So therefore, calcium carbonate is once again having both the types, right? Both the types are there. Lithium chloride, that is the answer. In lithium chloride, we have lithium ion, if not the lithium cation, and the chloride anion. So between lithium and chloride, you have the ionic bonds only, right? You have the ionic bonds only. So therefore, we have to accept the answer lithium chloride. Quickly tell me whether the explanation is clear enough, because I'm almost new to you. So therefore, I need to know whether the speed is manageable or the explanation is clear enough. Clear, eh? Right. Thank you. Then we'll go to the second one. As I proceed parallel to me, quickly take down the explanations and whatever the pictures that you feel like drawing, quickly jot it down. Then the second one. Which of the following can be considered as a neutralization reaction? Right? Neutralization reaction. So when it comes to the neutralization, Lamai, neutralization is basically happening between an acid and a base. All right. When an acid and a base is reacting, we refer to that sort of a reaction as a neutralization reaction. So if you look at the first one, calcium carbonate going to calcium oxide and CO2. So there basically what happens is calcium carbonate is breaking. You have one component at the beginning. At the end, it's turning to more than one components. So that means simply the one you have got at the beginning, you are breaking that into pieces. So first one is also first one and fourth one. If you look at the first one and the fourth one, in both the situations, what has happened? At the beginning, you have one and it's going to more than one. So the simple idea is that compound is breaking. So those reactions are falling under decomposition reactions. You're decomposing. So if you take the second one, copper 2 plus is accepting 2 electrons to go to copper. Right? Copper 2 plus is accepting 2 electrons to go to copper. So there, if someone is accepting electrons, what is a reaction? What do you call that? Quickly let me know. Right, it's a reduction. So if someone is accepting electrons, that is a reduction. So the second one is a reduction. All right, second one is a reduction. I will take these two ticks away. All right, so this one I discussed, this one I discussed. Second one is a reduction. And when it comes to the third one, calcium hydroxide and H2SO4. Calcium hydroxide is a good base. H2SO4 is a good acid, right? It's a strong acid. So here you get acid reacting with the base. So when acid is reacting with the base, that is what we refer to as a neutralization reaction. So that is resulting in the respective salt and the appropriate number of water. So then this is the neutralization reaction. And there's a question, I think this is for the first one. Miss, how to identify whether it's an ionic bond or a covalent bond? I will give a short answer to your question. one parameter you can consider is the electronegativity difference. If the electronegativity difference is high, that is more towards the ionic bonding side. That's one point. Second one is, there is a major difference between the ionic bonding and covalent bonding. In the ionic bonding, one person is releasing the electron. Now, for example, sodium chloride, sodium is completely ejecting the electron and it's coming to the cation. And thereafter, sodium ion has no relation to the electron it released. And then that electron is accepted by another one, which is chlorine. And thereafter, the electron is entirely belonging to chlorine. So therefore, in the ionic bonds, cation and an anion is involving. And in the covalent bond, it is always going with the sharing of electron, right? It's going with the sharing of electron. So in the covalent bonds, there's no concept like one person is releasing the electron and the other one is accepting the electron. No. If two people are there, one is donating one electron per bond, other one is also giving one electron, then they have two electrons. Both the electrons are shared by both of them. All right. And another one, reactions between nonmetals and nonmetals considered as covalent bonds. It's not always like that. Sometimes covalent bonds are happening between two metals also, sometimes between metals and nonmetals, sometimes between nonmetals. So when it comes to the covalent bond, what really matters is not whether nonmetal or a metal is participating, right? Between nonmetal and nonmetal, metal and metal, nonmetal and metal. In all three compositions, we can see covalent bonds. So therefore, the 2 points I highlighted, those are the concepts. Right. So then question number 3. How many moles of sodium thiosulfate is there in 15.8 grams? So here I have given you a certain mass, right? This is symbolized using simple M. I have given you mass. And I'm asking for what? Number of moles. This is denoted using simple M. So the simplest equation which is connecting simple N and simple M is simple N equals to simple M over capital M. So through this relationship, understand, if you know the number of moles of someone, listen to me very carefully. If you know the number of moles of someone, you can definitely find the mass. Because capital M, if you have the periodic table, molar mass of anyone we can find, right? Molar mass of anyone we can find. If the relative atomic masses are given O, if you can get access to a periodic table, capital M, we can very easily find. So therefore, if you know the number of moles, we can directly relate that to the mass, and the vice versa is also possible. If you know the mass of someone, you can easily connect that to the number of moles, because once again, that connection is coming through the molar mass. So always keep in the mind, finding the molar mass is nothing if you know the relative atomic mass is O, if you can get access to the periodic table. So then here we can easily go with this one. Then I have to find the molar mass. So in sodium thiosulfate, there are 2 sodiums, 23 by 2, that is 46, 2 sulfur, 32 by 2, 64, 3 oxygens are there, 16 by 3, 48. Then you have here 8, from this altogether 158. So this is 158 grams per mole. So that is the capital M, right? That is a capital M. So then to find the number of moles, the mass given is 15.8 grams divided by 158 grams per mole. So thereby we get the number of moles as 0.1. It's a very easy simplification. It's very easy. So then we can take the answer as second one. Right, quickly take this one down. Right, so then we'll take the next one, number 4. Can I know whether the question number 3 is completely understood? All of you? Right. Okay, then we'll take the 4th one. So there I am asking, out of the oxides given below, which one is the most basic oxide? I'm asking for the basic oxide. All right. So carbon dioxide, that is an acidic oxide, right? Carbon dioxide is an acidic oxide. Sometimes you might have heard, because of CO2, when it comes to the normal rain, not the acid rain, even the normal rain is little bit acidic. That is due to the dissolution of CO2 in rainwater. So CO2, this is an acidic oxide. When it comes to SO2, SO2 is also an acidic oxide. What do you know about aluminum oxide? Any comments to aluminum oxide? All right, aluminum oxide is amphoteric, right? It's a famous amphoteric oxide, aluminum oxide. Magnesium oxide is basic, right? Magnesium oxide is basic. So if you align them in a certain order, least basic means most acidic, right? Least basic means most acidic. So then I'm asking for the most basic one. So this is out because it's acidic. This is out. This is also acidic. Amphoteric means what? What do you understand by the word amphoteric? We will quickly refresh that part also. What is the real meaning of amphoteric oxide? So amphoteric means they have the ability to react with both acids and with bases, right? They can equally react with acids and bases. So when they are reacting with an acid, they are acting as a base. When they are reacting with the base, they are acting as an acid. So both acidic and basic properties are there. So magnesium oxide is just basic. So we'll take the answer as magnesium oxide. That is simply a theory-based question. Right, then we'll go to the 5th one. This answer here, amphoteric, I have received one answer telling that neither acidic, no basic. Right, neither acidic, no basic. No, that is not the idea of amphoteric. You can say it's neither acidic, no basic, probably when it comes to neutral compound. Amphoteric means both the capabilities are there, right? Acidic properties also there, basic properties also there. Both the capabilities are there. That's what you mean by amphoteric. Right. Then we'll take the 5th one. Which of the following correctly interprets 1 mole? 1 mole concept. Right? 1 mole concept. If you take 1 mole, quickly recall what you understand along with this word 1 mole. I'm telling I'm taking 1 mole of something. Say I'm taking 1 mole of phones. What have I actually done? If I take 1 mole of phones, what have I done? I have taken 6.022 times 10 to the power 23 many moles. Sorry, 23 many phones, right? If I'm referring to 1 mole of phones, if I refer to 1 mole of pens, I need to take this many pens, right? So if you relate this to a simple thing that we use in the day-to-day life, we all know 1 pair, right? Inside 1 pair, we have 2 things, right? 1 pair means it's including 2 things. 1 dozen, inside 1 dozen, you have 12 things. If you take 1 dozen of books, that means you are taking 12 books. So similarly, this 1 mole is falling into this 1 pair, 1 dozen, 1 mole. It goes in that order. So like we have 2 things inside a pair, like we have 12 things inside a dozen, inside 1 mole, we have 6.022 times 10 to the power 23 many things. So we give a special word to this number, that is the Avogadro's constant, right? That is Avogadro's constant. So simply get the idea. Like you have 2 inside a pair, like you have 12 inside a dozen, you have Avogadro number of things inside 1 mole. So Avogadro number is a huge number, right? It's a huge number. So then we want to check which one is giving that Avogadro number. Avogadro number interpretation, right? Then we'll take 1 by 1. If the relative molecular mass of CO2 is 44, so again understand, since I am referring to relative molecular mass, this is unitless. Relative, no, so unitless. The mass of 44 CO2 molecules is 1 mole. What do you think? That statement is wrong, right? If you take, if I have given the statement like this, if you take 44 grams of CO2, inside this 44 grams of CO2, you will get 1 mole of CO2 molecules. That means Avogadro number of CO2 molecules. But here I have given it in a wrong way. Mass of 44 CO2 molecules is 1 mole. No. If you take 44 grams from CO2, inside that mass you have 1 mole. Understand the statement carefully. And the second one. Right? Second one. If the relative atomic mass of sodium is 23, number of sodium ions in 23 grams is 1 mole. There, do you know what is the relative mass of sodium? By looking into the information I have given for the statement 2, can you tell me what is the relative atomic mass? Relative atomic mass of sodium. That is also 23, right? Right? That is also 23. Okay. So then sodium is 23. Then how come sodium plus is also 23? All right. Now I'm telling, not actually me, you said sodium is 23. Right, I accept it. Then here I have given the information sodium plus. This is also 23. Is this sensible? Can you say okay to this? Both of them are 23? Right. So then this is a point. This is correct. This one we can accept. The reason is always when you are taking the mass of a certain element or a molecule, what we consider is the mass of the protons and the neutrons only. Right? We always go with the mass of protons and neutrons only. We don't forget about, we forget about the mass of electrons. Right? We forget about the mass of electrons. Is it because the electrons are not having a mass? Is it because electrons are not having a mass? No. Electrons do have a mass, But compared to the mass of a proton or a neutron, electron's mass is negligible. Right? Compared to the mass of a proton or a neutron, electron's mass is negligible. Don't get it in a wrong way. We are not accounting for electrons because electrons are not having a mass. No, electrons do have a mass, but its mass is negligible compared to the mass of proton or a neutron. So therefore, when we are coming from sodium to sodium plus, we are ejecting one electron, right? We are ejecting one electron. So that means we are losing one electron. So since we are not worrying about the mass of an electron, sodium's mass and sodium plus ion mass, both of them are going in the same scale. So therefore, this statement is correct. We'll read it again. If the relative atomic mass of sodium is 23, yes. Now here also you can see the information in the question above. I'm giving the condition here. If the relative atomic mass of sodium is 23, the number of sodium plus ions in 23 grams is 1 mole. That is correct. So here, if you take 23 grams from sodium or sodium plus, both of them are actually correct. If you take sodium, inside that you have 1 mole of sodium atoms. If you take 23 grams from sodium ion, inside that you will get 1 mole of sodium ions. So second statement is correct. Third one, if the relative atomic mass of sodium is 23, number of sodium plus ions in 22 gram is 1 mole. So don't get misled because of the statement I'm telling here. Always be mindful. True that when you are coming from sodium to sodium plus, we lose one electron, right? We lose one electron. So if you are taking 1 mole of sodium coming to 1 mole of sodium ions, we are losing 1 mole of electrons. In this transformation, we are losing 1 mole of electrons. But 1 mole of electrons is not accounting for 1 gram. Now here, if you see the mass difference, 23 here, 22 here. Just because you are losing 1 mole of electrons, that is not accounting for 1 gram, right? Stay mindful, electrons do have a mass, but compared to the mass of a proton or a neutron, its mass is negligible. So therefore, when you are taking the mass of any element or ion or compound, we don't care for electrons, right? We don't care for electrons. So here, the statement is wrong because of the mass I have suggested here. Last one, if the relative molecular mass of glucose is 180, the number of carbon atoms in 180 grams of glucose is 1 mole. I will show you the calculation for this one. We'll first find how many moles of glucose is there. I have given you the mass, 180. Relative molecular mass of glucose, 180 means molar mass is 180 grams per mole. So this is again N equals to simple M by capital M. So this to this cancels. Number of moles of glucose is 1 mole. A glucose formula is C6H12O6. So inside 1 mole of glucose, how many carbon moles are there? Again, I'm filling the question. Inside 1 mole of glucose, how many carbon moles are there? Right, 6. 6 carbon molecules, 6 carbon moles are there, right? Inside 1 glucose, if you are taking 1 mole of glucose, 6 moles of carbons are there. Similarly, if you take hydrogens, 12 moles of hydrogens are there. If you take oxygen again, 6 moles of oxygens are there. So here I am hitting on the carbon atoms. So it is actually accounting for 6 moles, not for 1 mole. So because of that, this statement is also wrong. So the correct one would be the second one. So through this question, I'm trying to cover 2 points. First one is to bring the idea about the 1 mole. And the second one, the fact that electron's mass is negligible compared to the mass of a proton or a neutron. But stay mindful, electrons do have a mass. It's only its mass is negligible. Right. Clear enough? All 4 statements, especially when it comes to the wrong statements, do you understand why that is wrong? Okay. Then we'll go to the 6th one. Moving. So 6th one is asking, what is the mass of CO2, sorry, O2, not CO2, O2 required to completely combust 2 moles of ethane? Now here I have given only the name, right? That means you have to write the formula of ethane. So ethane is an alkane. Alkanes are hydrocarbons. Hydrocarbons means the compounds having carbon and hydrogen only. So ethane means the alkane with 2 carbons. First one is CH4. This is methane, right? This is methane. Next we get ethane, C2H6. So this is ethane. Then primarily you need to know the formula of ethane. So that is C2H6. Then we need to write the combustion reaction for C2H6. So combustion, definitely oxygen is required. When you are combusting the hydrocarbon, all the carbons are sent to CO2. Hydrogen is going to water. If you balance this, because you have 2 carbons here, 2 CO2s are coming, 6 hydrogens here, therefore 3 water coming, 3 times 2 is 6 here. Then oxygens altogether, here 4 oxygens, with this 7 altogether. So because we have 2 here, I can put it as 7 by 2. Again, don't forget, I'm asking for 2 moles of ethane. So this balancing is covering up only for 1 ethane. I need to cover up for 2 ethanes. So therefore, I have to multiply the entire reaction by 2. So when everything is multiplied, we understand now our concern is oxygen. So you don't have to rewrite everything, right? These are MCQ questions. So always keep in the mind, what is the question asking from you? If the question wants you to chase behind oxygen, there's no point of you multiplying CO2 and water by 2 and writing 4 CO2 and 6 water here. It's just a waste of time. So we'll take only the oxygen. So when you multiply this by 2, it's coming to 7 oxygen. 7 oxygen moles. I'm asking for the mass, right? I'm asking for the mass. So I highlighted at the beginning, if you know the number of moles of someone, you can easily go to the mass. If you know the mass of someone, easily you can come to number of moles. Because simple N and simple M, right? Simple N and simple M. These two are getting bridged through the molar mass, right? Those two are getting bridged through the molar mass. So molar mass we can easily find, right? We can very easily find. So therefore here, I'm asking for the mass thing. The basic equation is like this. I will subject simple N, then it is simple N times capital N. Then simple N here, 7. Capital M, oxygen's relative atomic mass. I haven't mentioned the relative atomic mass here. It has to be 16, right? It has to be 16. So oxygen gas, that is O2, therefore it is 32 grams per mole. Then it is coming as 7 by 32. All right, 7 by 32, then it is 224 grams. Check to see whether I have done any mistakes. Oh, am I correct? Now you can check on my work. So I will again go through the question. First, you need to know the formula of ethane, C2H6. Then I wrote the combustion reaction for ethane. And there's a keyword in the question I have to address for 2 moles of ethane. So that means the entire reaction should be multiplied by 2. Since our concern is on oxygen, I multiplied only that. Then it's coming to 7 oxygen, 7 moles. Then I can find the mass through this equation. 7 times 32 grams per mole, because the relative atomic mass of oxygen is, here I'll put it, 16. So that information, take it in. Right, the work is correct. So the 7 oxygen part is coming here by multiplying the equation by 2. Right, because we have to account for 2 moles of ethane. So when you are multiplying this by 2, you have to multiply the equation throughout. So when you take 2 here, this is also multiplied by 2. So when you are multiplying that by 2, 7 by 2 times 2 means 2 to 2 cancels, you get 7. That's how I got the 7. Is that clear to you now? How I got that 7? By 2 times 2, that is 7. All right. 7 by 2, that is a coefficient I had got earlier. Since I have to multiply the entire equation by 2, this is also multiplied by 2. Then 2 to 2 cancels. Then we get 7 moles of oxygen. Others, is that clear to you? Okay, ne? Right. Then we'll proceed to the next one. 7. Which of the following statements is incorrect? Again, please take care. I'm asking for the incorrect statement. When the surface area of the reactants is high, reaction rate is high. That statement generally correct. Because when the surface area of the reactants are high, it's leading to more collisions. So more collisions means we can expect more products to get formed. Right? High surface area means it's giving the chance for more number of collisions. More number of collisions means it's leading to more products. So that means more number of products are getting formed within a given amount of time means rate is high. Always the rate is how many products can you form within a given amount of time. All right, within a given amount of time. So then within a given amount of time, we are forming more products means reaction rate is high. Second one, K2MnO4 is a purple color compound. Right, there's a request asking me to increase the screen size. Is it clear enough now? I hope it's good now. Right, okay. What item is in the second statement? K2MnO4 is a purple color compound. This is wrong. K2MnO4 is not what is purple. Instead, that is KMnO4. Potassium permanganate is what is purple. Then who is this? So look at this two. This is K2MnO4. This is KMnO4. This is potassium permanganate. This is called as potassium manganate, right? Potassium manganate. Potassium manganate's color is green. Potassium manganate's color is green. So therefore, don't get confused. Read the question carefully. Notice that it's not potassium permanganate. Third one, in an exothermic reaction, the energy of products is less than the energy of reactants. In an exothermic reaction, what is happening to energy? I mean, basically the reaction is absorbing energy or is it releasing energy? Exothermic. Releasing or absorbing energy. All right, it is releasing energy. So when the energy is released, what is happening to the reactants? Their energy is going down, right? Initially, they are at a certain energy level. Since the energy is released, they are coming down, 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 down. All right. With the liberation of energy, they come downhills. In an energy profile, they come down. Their energy is declining. So therefore, if you interpret that one, this is a rough sketch. This is the energy axis. Reactants will be at a top level. Products are here. So when reactants are coming towards products, energy is given out. So therefore, here I am telling, in an exothermic reaction, energy of products less than the energy of reactants, yes. Last one, zinc can undergo oxidation better than copper. Zinc can undergo oxidation better than copper. That's a very famous statement. You all know that zinc can undergo oxidation better than copper. So I will add one point to that, to your general knowledge, generally what you know. When you refer to the activity series, right? Activity series, so sometimes you may be calling it as a reactivity series or the chemical series. The elements which are at the top. Now, if I take zinc and copper, zinc is at the top, copper is at the bottom. Always the elements at the top, they prefer to undergo oxidation. Elements at the bottom, they prefer to undergo reduction. Right? Elements at the top, they prefer to undergo oxidation. Bottom ones, they prefer to undergo reduction. So that is not my point. This is it. Simply keep in the mind, electrons are flowing from top to bottom, as if water is flowing. We all know when it comes to waterfall, water is coming from top to bottom, water is falling down. So similarly, in the activity series also, electrons are flowing down, right? Electrons are flowing down. So electrons are flowing down means top people have to release electrons. That means they undergo oxidation. The bottom ones, they are accepting electrons. That means they undergo reduction. So this is my point. Right? In the activity series, electrons are flowing just as same as how water flows, top to bottom. So if you keep this point in the mind, you can apply that to any question. You can modify that and apply that to any question. So this statement is correct. So then incorrect statement is the second one. This K2MnO4's color, I have highlighted it. That's green. I have circled it using green. That is because it's green. Right. Question number 8. Which of the following is not a byproduct? Again, take care. A negation question is there. Not a byproduct in the production of salt. Right? Not a byproduct. So when it comes to the production of salt, what happens is you have large shallow tanks, then you have the medium tanks, then you have the small tanks. So in the large shallow tanks, when the concentration is almost twice, I'll keep it as 2C, C is indicating the concentration. When the concentration is as twice as the concentration in seawater, in the first tank, that means large shallow tanks, calcium carbonate is precipitating. In the medium tanks, right, in the medium tanks, when the concentration is increased to 4 times, 4 times means 4 times as the initial concentration, calcium sulfate is precipitating. So in the third tank, small tanks, when the concentration is increased to 10 times, there comes our important one, sodium chloride. So salt means sodium chloride. Right, in the general use, we address sodium chloride as our salt. Additionally, calcium sulfate is also salt. Right, if you take sodium bromide, that is also salt. But here, when we say production of salt, we are actually hitting on sodium chloride. So then we understand sodium chloride is our major product, right? That is what we are intending to form. That's what we want. So sodium chloride is not a byproduct. So this is the major product. So on our way to sodium chloride, we are forming calcium carbonate, calcium sulfate. They are precipitated and removed. So these ones are byproducts. They are byproducts. So byproducts means in addition to what we mainly focus, other stuff we are forming. So our focus is on sodium chloride. On our way to form sodium chloride, we are forming calcium carbonate and calcium sulfate. So then magnesium chloride, the first answer is magnesium chloride. Magnesium salts are there in salt. Because of magnesium salts, we get a small bitter taste in salt. If you have ever tasted just a normal salt, it's having a small bitter taste. That is because of the magnesium salts. So that is also byproduct actually. We are not separating it in large quantities, but as an impurity, it is there inside sodium chloride. Then sodium chloride is our major product. It's not the byproduct at all. So the answer is sodium chloride. Calcium carbonate and calcium sulfate, very clearly, we are separating those in the first 2 tanks. So here, clearly understand our main focus. Our main focus is sodium chloride. So it's not the byproduct, it's our major product. Right. Okay. Clear enough? So these things, quickly take it down. So you can run through this paper before your exam. So then when you see the question and the answer, especially with the explanation, that will be really helpful. Right, then we'll go to the next one. 9, in which of the following compounds does the central atom contain 2 lone pairs in the Lewis structure? See, in every single question, I have put a certain keyword. So here it's 2 lone pairs. I'm looking for 2 lone pairs. If you take CO2 is like this. I'm going with the dot dash structures. Central atom has no lone pairs. In ammonia, nitrogen has only 1 lone pair. I'm looking for 2. H2O, here on oxygen, we have 2 lone pairs. So this is the answer. And then HCl, in HCl actually, there's no atom to be called as a central atom because it's only a diatomic molecule. So neither hydrogen nor chlorine is becoming a central atom here. And on the other hand, hydrogen has no lone pairs. Chlorine has 3. I'm looking for 2. Right? I'm looking for 2. Right. So then answer is water. So better if you can take down the structures also. These are all simple structures and very famous structures. Then question number 10. Lamai, generally tell me, is the speed all right? Can you cope up with the speed? Okay. Yes, Nay. At any point, if you want me to slow down or if you want me to wait, no problem at all. You can drop a message. Right. We'll go to the 10th one. Select the correct statement. Right. After a long time, I'm asking for the correct statement about the subatomic particles. Subatomic particles means for your O-level level, you are learning electrons, protons, and neutrons as the subatomic particles. First one I'm telling, electrons are only subatomic particle type found outside the nucleus. Exactly correct. When you take a certain atom, nucleus is there, around the nucleus, energy levels are there. So in energy levels, you have the electrons, right? You have the electrons. So inside the nucleus, you have protons and neutrons. Electrons are always outside the nucleus. And essentially, and I'm emphasizing on that fact, electron is the only subatomic particle found outside the nucleus. All the other subatomic particles. Now for your O-level level, you are getting exposed to protons and neutrons only. But when you study science further, you will get to know that there are so many other subatomic particles in addition to protons and neutrons now found. So all those subatomic particles, they are also residing inside the nucleus. Electrons are the only subatomic particle found outside. Right. Next one. When forming cations, atoms accept protons. Wrong. When forming cations, what happens is electrons are released. Now, for example, we'll take sodium and sodium plus. So number of protons in sodium is 11. Number of electrons in sodium is 11. So their proton electron count is same. Why is that? Why are they same? Why are they same? Sodium proton count and the electron count same. What is the reason? Atom is an electrically neutral entity. Atom is electrically neutral. Electrically neutral means it's not bearing any charge. Not bearing any charge means it's not negative, it's not positive. It's neutral. So therefore, number of protons and electrons has to be same, right? Those two has to be same. Then the charges are cancelling out. Then when it comes to the cation, proton count is 11, right? Proton count is 11. How many electrons are there? Sodium plus. How many electrons? It is a simple question. Right, it's 10. So now what has happened? When sodium is going to sodium plus, what has it done? It has ejected one electron, right? It's removing one electron. So always keep in the mind, in chemical reactions, nucleus is kept intact. That means nothing is happening to the nucleus. The species found inside the nucleus, they are not involving in chemical reactions. Chemical reactions are always taking place with respect to the electrons. With respect to the electrons. So chemical reaction is always an electron business. Electron business means one person is giving out electron, another person is accepting electron. One type of a business. Another type will be two atoms are there. One is giving one electron, another one is giving another electron. So they share the electrons. Another type of a business. Sometimes some other types of sharings are also there. I will not go into that. So the simple idea is chemical reactions, they always involve just electrons. Nucleus is not participating. Nucleus is participating in nuclear reactions, right? They are not for your syllabus. So we have to discuss about the chemical reactions. They involve only electrons, maybe releasing electrons, maybe accepting electrons, maybe sharing electrons. So therefore, if cations are formed, electrons are ejected. If anions are formed, electrons are accepted. It's always an electron business, right? That's a word you can keep in the mind. That is an electron business. No other species is involving. Third one, mass number of an atom includes the mass of electron, mass of proton, mass of neutrons. Wrong. Mass number is including mass of protons and neutrons only. Again, I'm refreshing the point. Mass of electrons are not taken in, not because electrons are not having a mass. It is because mass of an electron is negligible compared to the mass of a proton or a neutron. So please be clear with that. Fourth one, isotope of H31 contains 3 neutrons. How many neutrons are there for this isotope? How many neutrons? So this one is telling it has 1 proton. And it is same as the number of electrons also, because we are referring to the atom. Then this 3 is indicating addition of protons and neutrons. 3 is indicating addition of protons and neutrons. That is equal to 3. We know proton count is 1. So the neutron count has to be only 2. Right? It's only 2, not 3 neutrons. This is wrong. Right. That is the 10th question. Answer is number 1. Then we'll go to the 11th one. So here, main idea is chemical reactions, they always involve just electrons. Electrons released, if not electrons accepted, if not electrons shared. It's all about electrons. Right, we'll go to the 11th one. There's a question related to the 9th one. 9th one, in what I read the Lewis structure, it comes like this. So on oxygen, you have 2 lone pairs. So I'm asking for the compound which is having 2 lone pairs on its central atom. So oxygen has 2, answer is water. Okay? Clear? Right. Then we'll go to the question number 11. Right. Here I have said solvent A is completely miscible in solvent B. Completely miscible. Right? If there is a considerable difference in their boiling points, what is the most suitable technique to separate A from B? What do you think? So here the keywords miscible, and there is a considerable difference in their boiling points, right? Difference in their boiling points. So when you combine those 2 features, not steam distillation, right? Steam distillation, right? Steam distillation is going with immiscible compounds, right? Steam distillation is going with immiscible compounds. especially when you're extracting plant materials. So we are using steam. So finally steam is converting to water and the essential oil is getting extracted out. So in the titration flask or the beaker to which you are collecting that, you will be clearly seeing two different layers. One layer is oil, one layer is water. So there the two things are not miscible in each other. They are immiscible. Steam distillation is going with immiscible compounds. So this is going with the fractional distillation, right? These two keywords are going with the fractional distillation. So some of you are telling the answer is simple distillation. No, not the simple distillation. In simple distillation, here you need to have one vaporizable compound, one, if not you can say volatile, one volatile compound, one non-volatile compound. So notice those things. Steam distillation is going with immiscible compounds, right? It's with immiscible compounds. Simple distillation, you have to have one volatile compound plus one non-volatile compound. Fractional distillation key point is definitely it's miscible, right? Definitely it's miscible. And then we are exploiting the fact that the components are having a considerable gap between their boiling points. That is why at different temperatures, right? At different temperatures, we can take different fractions out. So if you look into a certain fractionating column, so I will put a rough sketch here. In a fractionating column, at different levels, outlets are there, right? At different levels, outlets are there. So these outlets are maintaining at different temperatures. So from this outlet, the species whose boiling point is getting matched with this maintained temperature is coming out. At this outlet, it's maintained at a different temperature. The compound whose boiling point that is getting tallied with this is coming out. So in the fractional distillation, definitely it's a miscible system, miscible mixture. And we are using the fact that those components are having different boiling points. Solvent extraction, in solvent extraction, what you do is you're extracting a certain substance. If it is already in a less soluble solvent, you're extracting that to another solvent where it is more soluble. Now, assume that you have a solvent. In that one, some species is dissolved, but that species is not happy inside that solvent. So therefore, you are introducing a second solvent in which our substance is happily getting dissolved. So then when you introduce a second solvent and when you shake it, our substance is happily transferring, right? It's getting happily transferred to the next solvent and thereby we can extract it, right? So those are the concerns. So then we have to go with fractional distillation. What does completely miscible means? Completely miscible means, now for example, if I take water and ethanol, right? Water and ethanol, they are completely miscible. First you are taking a glass of water, to that you are pour some ethanol. And thereafter, ethanol is completely soluble. So the resulting mixture is a homogeneous one, right? You have a glass of water, to that you pour some ethanol. Since ethanol and water are miscible in each other, if not simply I can say soluble, then thereafter also you see a uniform solution, if not homogeneous solution. That means throughout the solution, you see the same composition. All right. Ah, yeah, yes, like homogeneous. If it is completely miscible, it's definitely giving rise to homogeneous solution. Right. Please tell me whether you all are clear with these key points. Steam distillation is going with what? Simple distillation, what is a concern? Fractional distillation, what is a concern? Solvent extraction, what is a concern? Right. Okay. Then we'll take the 12th one. When a solution of aqueous NaCl is electrolyzed using carbon electrodes, what is the reaction happening at the cathode? Right. What is the reaction happening at the cathode? Sodium chloride aqueous is electrolyzed, right? Sodium chloride aqueous is electrolyzed. So I will quickly refresh the electrolysis part. We'll switch to the whiteboard for it. Right. I will sketch the electrolysis. So meanwhile, I'm telling electrolysis. Why do we use electrolysis? What is the reason? What are we expecting from that? So electrolysis is primarily done when we want to get a certain reaction happen, right? Say that there is a certain reaction, spontaneously it's not taking place. So we have to exert a certain force on the reaction and then only it's happening. So electrolysis is used on such reactions. So the external force we are applying is the electric energy, right? Electric energy. In the electrolysis, electric energy is converted to chemical energy, right? This is converted to chemical energy. So when it comes to the electrolysis, the entire concern is we are getting a certain reaction done by force, right? We are getting a certain reaction by force. We forcefully do it. So the best way to identify an electrolysis system is you will be having an externally connected battery. Externally connected battery is there. Right. So then I will give a certain idea about the electrolysis. Check whether this explanation is making sense. If you have any questions, you can ask from me. Right. So the electrolysis main concern, I said, there are some reactions which are not spontaneously taking place. So we are forcing, right? We are forcing the reaction to take place. So when you are forcing, the force we are using is the electric force, electric energy. That force is given by the battery. So then now we are taking the NaCl aqueous now. Right, that is our electrolyte, right? That is our electrolyte. Then I will explain the entire electrolysis concept through this example. Listen to me very carefully. Now, when you take the battery, we all know the long hand is positive, short hand is negative. That you know in physics also, physics parts in the science, they also you are refreshing that. Now, when it comes to the chemistry, now we have two types of cells. The normal galvanic cells are there, electrolytic cells are there. In galvanic cells, we are using a certain chemical reaction to produce current. Right? We are using a chemical reaction to produce current. In the electrolytic cells, the reverse is happening. Using the electric energy, we are getting a certain chemical reaction done. Now, when it comes to those two types of cells, in one cell, anode is negative, in one cell, anode is positive, and in one cell, cathode is negative, and in the other, cathode is positive. It's a bit confusing thing. No? Sometimes you might have memorized that one. Here, I will give a certain logical explanation to figure it out and to figure out all the reactions along with that. So we are starting off with the external battery, right? Externally connected battery. There I first connect the, first I denote the positive terminal and the negative terminal. And then the rod which is connected to the positive terminal is positively charged. The negatively charged terminal is getting connected to the negative rod. If not, the rod that is getting connected to the negatively charged terminal of the battery is negatively charged. Simply positive to positive, negative to negative. And thereafter, I'm giving a famous concept. That is, in a battery, right? In a battery, when the current is flowing, current is going from plus to minus or minus to plus. Conventional current. Conventional current is going from plus to minus, right? Conventional current is going from plus to minus, right? Then can I mark the current flow like this? Can I mark the current flow like that? No, of course not. The reason is, right? The reason is through the battery, current is not flowing, right? Through the battery, current is not flowing. So that is what is symbolized because of the space that we are keeping when you are denoting the battery. There is a space here. This white is representing that. Current is not flowing through the battery. Current doesn't flow. So then current should be flowing from positive to negative terminal through the external circuit. Through the external circuit means not through the battery, but in this path. That is a conventional current. Then the electrons are going in the opposite direction, right? Electron flow is in the opposite direction. Then I'll denote the electron flow. Electron flow should be going like this. What I want here is the electron flow. So then understand the negative portion, if not the negative terminal of the battery is shooting electrons out, right? It's shooting electrons out. So therefore, the electron flow is coming down like this. Right. After electrons come to the edge of this rod, what is happening? Will they jump into the solution and swim and go to the other one? Because now they have to somehow complete the circuit. Will they? No. Electrons cannot swim. That is a famous saying in the electrochemistry. Electrons cannot swim. Right? Electrons cannot swim whatsoever. Electrons cannot swim. So therefore, this electron movement is only up to here. But there's a special thing happening to the battery. Battery's negative terminal knows that it released electrons. Then somehow, after a while, positive terminal is feeling the electrons are somehow coming back. Right? Negative terminal is releasing the electrons. After a while, positive terminal is feeling the electrons I released from my negative terminal is coming back to my positive terminal. So then if I'm telling that the electrons cannot swim, how can we connect these two? So this is what is happening. The electrons that come down, they are going up like this. This is the electron flow. But a special thing is happening to cover up for this path. A species from this rod, species that is close to this rod, has to accept the electrons. Right? Now say that there is a certain species here. This fellow is accepting the electrons. And there is another person here. This one is releasing electrons. This one is collecting the electrons. Other one is releasing the electrons. Battery simply doesn't know what is happening underneath. Battery doesn't know it, no. And battery cannot see either. But here, right, inside water, inside the electrolyte, this kind of a process is happening. Someone is accepting the electrons, someone is releasing the electrons. So then, after all, right, after all these things are done, battery is feeling right, my negative terminal is releasing electrons, and my positive terminal is somehow getting those electrons back. All right, they are getting the electrons back. So then we can very logically understand if this species is accepting electrons, what is the reaction that is happening there? Accepting electrons means it's a reduction, right? Reduction is happening at that. If someone is releasing electrons, what is that? Oxidation, right? Oxidation. So it's not nice for me to keep two human beings there. So we will switch to the appropriate chemical species. Now, the secondary concern. We have the sodium chloride aqueous, right? Sodium chloride aqueous is there. Carefully understand, sodium chloride aqueous means sodium chloride and water. Sodium chloride and water. Aqueous ne? From sodium chloride, I have sodium and chloride. From water, it's giving little bit of H plus and OH minus. Small amount of H plus and OH minus is there. Then next what happens is the negatively charged terminal. Now, how do we know that this is negatively charged? Because it's connected to the negative terminal of the battery, right? Very simple. Then the negative rod is attracting the positive ions, right? Negative rod is attracting the positive ions. Who are the positive ions? Sodium and H plus. Sodium and H plus. Positive terminal is attracting the negative ones. Who are the negative ones? Cl minus and OH minus. Right? Cl minus and OH minus. Then we have to think about the reactions. Right? We have to think about the reactions. Before that, I will tell you, always the reduction is happening at the cathode. Right? Whether you are referring to a galvanic cell or to an electrolytic cell, whatever the cell type that you are dealing with, cathode is always having a reduction reaction. Anode is always having an oxidation reaction. I will give a small tip to keep that point in the mind. Anox, just keep this word in the mind. Anox, anode oxidation, right? Anode oxidation. Anode oxidation. If the oxidation is happening at the anode, at the cathode, obviously reduction should be happening. Whether this is galvanic or electrolytic or whatever the cell type, anode oxidation. What changes from cell type to cell type is the polarity of the anode. So those things you can very logically take. Right, now we have to take the reactions. So this is a reduction. The question is also talking about the reduction. Out of sodium and hydrogen, now we have to refer to the reactivity series. Sodium and hydrogen, hydrogen is below sodium, right? Hydrogen is below sodium. So then I said in the reactivity series, the ones at the bottom, they prefer to undergo reduction. So then out of these two, hydrogen is getting the chance to undergo reduction, that we can write as 2H plus aqueous, 2 electrons goes to H2 gas. Then when it comes to the anode, right, anode, Cl minus and OH minus, both of them can undergo oxidation, right? Theoretically, both of them can undergo oxidation. But when there is a halogen, now Cl minus is a halide, it's coming from the chlorine halogen. When there is a halogen, if not halide ion, definitely the halide ion is oxidized, right? For UR level, that is enough. If you have a halide with any other anion, maybe carbonate, sulfate, sulfite, nitrite, nitrate, among any of those anions, if you have a halide, definitely the halide is oxidized. So therefore, Cl minus is oxidized to form Cl2 plus 2 electrons. So this is the oxidation reaction at the anode. This is the reduction reaction at the cathode. Tell me whether this explanation is clear enough for the electrolysis. So this is the pretty basics. Right. It's very logical. Start from the battery, put plus minus, and then Accordingly, put the polarities for the two rods, positive to positive, negative to negative. Then think about the electron flow. And I essentially said electrons cannot swim. So therefore, their journey is ending here. Then someone has to accept those electrons. And on the other hand, we have to cover up the circuit also. Then someone has to release electrons at this end. Then those electrons are climbing up. And reduction is always at the cathode, oxidation at the anode. Don't try to remember both. Just keep only one in the mind. Then other way around is happening for the other. So then the cathode reduction out of sodium and hydrogen, the one at the bottom is getting the chance, which is hydrogen. For the oxidation, I simply said, if you have a halogen, now here Cl minus and OH minus, both of them are there. If you have a halogen, don't even look at the other anion. That is only an exam tip I'm telling you. When it comes to A levels, you will be getting a proper explanation for that as to why we are treating Cl minus or any other halogens over OH minus. So for your O levels, I'm simply telling, if there is a halogen with any other anion, don't even look at the other anion. Give the chance to halogen that is undergoing oxidation. Right. Then I'll get back to the paper. Halogens means, is that the question? Halogens means group 7 elements: fluorine, chlorine, bromine, iodine. Those are called halogens. Their anion is called halide. All right. Group 7. Group 7 species are called as halogens. Right. Then I'm moving. Then we can directly take the answer here. Aqueous sodium chloride, electrolyzed using carbon electrodes. What is the reaction happening at the cathode? That is a reduction. I explained that it's 2H plus is going to H2. 13. Which of the following is not true related to the industrial production of sodium? Right? I'm again asking for not true statement. So take care. Sodium is industrially produced in the down cell. Yes. Down cell. There is a certain syndrome called Down syndrome. I don't know whether in biology you are learning that one, but sometimes you might have heard the word Down syndrome. So by any chance, if you forget the name of the cell, just recall the syndrome. That is Down syndrome. And the second one, raw material is NaCl liquid. Yes. That is essentially molten sodium chloride, not sodium chloride aqueous. Third one, cathodic reaction. Now, I will quickly put up the setup for the sodium chloride electrolysis. Now, liquid sodium chloride. This is having NaCl liquid now. Electrolysis, I am getting the battery. Always a positive, negative, doesn't have to be like this. You can switch it. What did I say? Put the plus here, minus here, here plus, here minus. Electrons come from the negative terminal. Electrons come down. Reduction here, because someone has to accept electrons. Electron flow is climbing up. Here oxidation. Then think about the ions. We have sodium ion here, chloride ion here, because it's NaCl liquid only. Then sodium plus is going to the negative terminal. Negative 1 is going to the positive terminal. Right? It's going to the positive terminal. So reduction, there's only one species to undergo reduction. So Na plus liquid is taking an electron to go to sodium liquid. Here Cl minus is the one and only chloride. Sorry, one and only anion. So it goes to Cl2 gas. So here only one cation, only one anion. So sodium is the one and only. So no option, sodium is undergoing reduction. So there's no chance for hydrogen because simply there's no hydrogen, right? There's no hydrogen. No? So if you are not having hydrogen, there's no way for hydrogen to undergo reduction. And the fourth one, Cl2 is forming as a byproduct. Yes, ne? See, from the oxidation, Cl2 is coming. Cl2 is coming out as a byproduct. Correct. So the not true statement is the third one. Is that electrolysis is clear? So stay mindful whether we are dealing with sodium chloride liquid or sodium chloride aqueous. Okay, all of you. Right. Then we'll take the 14th one. Inside an aqueous acetic acid solution, which of the following is not found? Now, acetic acid solution, acetic acid is a weak acid, no? Right? This is a weak acid. So acetic acid is a weak acid means there are two words you need to understand, weak and acid. So because it is an acid, it is releasing H plus. Right? Acids, usually they release H plus. Because it's a weak acid, its ionization is partial. So it's releasing acetate plus H plus. So because it's an acid, H pluses are coming out. Because it's a weak acid, it has a partial ionization. It has a partial ionization. That's how you tally the two words. And aqueous solution, water is also there. Water is also slowly releasing very small amount of H pluses and OH minuses. Right. So then when you take an aqueous solution of acetic acid is there, acetate, H plus, water, OH minus. From what H plus is getting repeated. OH minus, yes, we get a little bit of OH minus from water. This is correct. CH3COO plus, it has to be minus, wrong. The correct one is CH3COO minus, that is acetate. This formula is wrong. Acetic acid, yes, because all the acetic acids are not undergoing dissociation. You have some undissociated acetic acids, right? Water, again, because this is a partial dissociation, undissociated water molecules are remaining. So then the answer is the second one. So clearly understand what do you mean by an acid? What do you mean by a weak acid? Acid means it releasing H plus. Weak means that releasing is partial. Okay. Understand the meaning of those words, plus understand how you can apply them. Because in the exam, ultimately, you have to go and perform. No? So perform in the sense what you have been learning in grade 10 and 11. Basically, you have to go and show your talent by answering a question. Answering a question means you have to simply apply what you have learned. So exam is simply application, right? Application. Right, you want me to explain the dissociation of a strong acid, right? So if you take HCl, HCl is a strong acid. So again, because HCl is an acid, it releases H plus. Strong means it's completely dissociated, right? Acid means H pluses are coming. Strong acid means it's a complete dissociation. That is a difference between weak and strong. What is released in the base solutions? OH minus. Instead of H plus, bases will be releasing OH minus. Right. The one who asked the strong acid question, is that clear to you now? Right. Then we'll go to the next one. Question number 15. A metal M forms an oxide M2O3. What could be this metal? So M2O3 means the oxide of the metal. No? So oxide is O2 minus. Then our metal has to be, it is bearing a certain charge. The number that is coming next to M is the charge of oxygen. The number that is coming next to oxygen is the charge carried by M. Then what is the charge of M here? What is the charge of that cation? It is 3 plus, right? So when you put this 3 here, 2 here, you have to basically exchange the numbers. No? 2 comes here, 3 goes there. This is resulting in M2O3. So then if you take sodium, sodium is forming sodium plus because it's from group number 1. Magnesium is forming magnesium 2 plus because it's from group number 2. Aluminium, it's from 3, so it goes to aluminium 3 plus. This is a sensible metal. And potassium, once again from first group, it forms K plus. Right, it's a small one. So here, basically I said, in M2O3, this is the oxide of the metal. Oxide means O2 minus, right? O2 minus. So then when you are writing the formula, you are basically exchanging the valencies. No? So this 2 minus this 2 is what is going to this M here. The 3 that is coming to oxygen, it is coming from the valency of M. Because M is the cation, it has to be 3 plus. So 3 plus is usually coming from group 3. Aluminum is there from group 3. All right. Right. Then 16th. Which of the following can conduct electricity due to freely moving ions? Freely moving ions. Graphite, tell me, can graphite conduct electricity? Can graphite conduct electricity? Yes or no? Yes. How come graphite conduct electricity? Because of what? Electricity this can conduct. That is because of the freely moving electrons. Right? Here I am writing only the electrons, but it's actually freely moving electrons. Sodium, it's a metal, can conduct electricity. That is once again because of the freely moving electrons. KCl solid, it cannot conduct electricity. Why? Is it because KCl is not having ions? Huh? Is it because KCl is not having ions? Then, when it is a solid, what is the problem? When it is a solid, yeah, what is the issue? Ions are there, but ions are not freely moving. If not, we can say ions are not mobile, right? Ions are not mobile. So therefore, understand ions are there. Since ions are not free to move, this is not conducting electricity. Sodium chloride liquid, this can conduct electricity, and it's because of the ions. Sodium chloride liquid means the molten state. There are sodium chloride lattice is broken to Na plus and Cl minus. So then I'm asking for the one who can conduct electricity due to freely moving ions, that is sodium chloride. Right. 17th. Which of the following statement is wrong about catalysts? Again, I'm asking for the wrong one. I actually intentionally put these wrong, incorrect words because you have to get exposed to that and you need to practice more on that question pattern. Because otherwise, you will be doing a lot of silly mistakes in the exam because you're not reading the question properly and because you don't understand what is asked in the paper, you all are answering something that is there in your mind. Then the marking scheme is not carrying marks for the answer that you wrote for the question that was in your head. So always read the question carefully and understand the question that is given in the paper because you have to answer for that question only, right? If it is asking for the correct one, mark the correct one. Wrong one, mark the wrong one. Right, catalyst. They increase the rate of a reaction. Obviously, that is a primary job of a catalyst to accelerate the reaction. They don't take part in reactions. What do you think about that? Are they not taking part in a reaction? Are they not taking part in reactions? Oh, they do, right? Second statement is wrong. Yeah, exactly. They take part, but they don't get consumed. Right? We can't say the catalysts are not taking part in the reaction. They do take part. They participate. So simply what they do is they come, they get involved in the process, and they accomplish their task, and then they slowly they move out, right? They come, they get involved in the reaction, they are doing whatever the job that they're supposed to do. After finishing their job, they are going out, right? They are going out. They are not getting overall consumed. Overall consumption is not there, but they do take part in the reaction. Just imagine without taking part in the reaction, how would they accelerate the reaction rate? They have to give a certain participation. Right. Third one, they don't get consumed at the end of the reaction. Yes, they don't get consumed. That is true. Catalysts are reaction specific. Yes. From reaction to reaction, we have to choose catalysts. After taking one catalyst, we can't expect that to accelerate all the reactions that is there in the world. They are substrate specific. If not, we can say reaction specific. The meaning of the reaction specific means for one reaction, you take one catalyst. For another reaction, you have to take another catalyst. If you go with completely a different reaction, a completely different catalyst you have to occupy. One catalyst is not accelerating one entire set of reactions. Reaction specific, or else you can say substrate specific. All right. Clear enough? Right. Then we'll go to the 18th one. I have given you a cell here, and I'm asking for the true statement. This time, true statement about the cell. So when you look into the cell, it's clearly visible that we don't have a battery here, right? We don't have a battery there. So if you are not seeing a battery, this is not an electrolytic cell, right? This is not an electrolytic cell. This is a usual galvanic cell. So in the galvanic cell, what happens? Chemical energy. This is being converted to electrical energy. That means using a certain reaction, we are producing current. Right? Using the chemical energy, if not using a chemical reaction, we are producing the current. Then we'll understand how the electrons are flowing here. Now, externally, we are not giving electrons, right? Externally, we are not giving electrons. That is happening in the electrolysis. Now, here, using the reaction, they are circulating electrons. Then we have to understand out of these two, who can undergo oxidation, zinc or copper. When you place them in the activity series, zinc at the top, copper at the bottom. I said electrons are flowing like water is flowing, top to bottom. So then zinc is undergoing oxidation. At the copper electrode, reduction will be happening. Then when this is undergoing oxidation, zinc rod is dissolving, right? Zinc rod is dissolving and it is releasing zinc 2 plus to the solution. Then the electrons are sent to copper electrode through the external circuit. Why? Now zinc 2 pluses are getting released to the solution. Can't it release electrons also to the solution? No, never. What is the basic concept? Electrons cannot swim, right? Electrons cannot swim. So therefore, electrons are not released to the solution. They are being circulated only through the external circuit. Then electrons are coming to the copper rod. Then electrons come down, down, down. Then what should happen? A certain species at this rod should accept the electrons, right? Should accept the electrons. Now here, carefully understand, for the oxidation part, I simply said zinc is oxidized, right? Zinc is oxidized. So in that case, zinc is undergoing oxidation to zinc 2 plus plus 2 electrons. Then when it comes to the reduction, can't I say copper is undergoing reduction? Copper is taking electrons. Then it will form Cu minus, if not Cu2 minus. No. Have you ever seen Cu minus? Have you ever seen Cu2 minus? No. Those kinds of ions are not existing. So therefore, understand, at the copper rod, a reduction is happening. That doesn't mean copper is reduced, because metals from the elemental form to an anionic form, a reduction is not happening to metal, right? Cu minus, Cu2 minus, such ions are not there. So therefore, when this electron flow come down, right? When it comes down, a species from the medium has to accept the electrons. Then who are the species in the medium? This is dilute H2SO4. So then in this medium, you have H plus and sulfate. So from H plus and sulfate, who can accept the electrons? Understand, sulfate is already negatively charged. It is having 2 minus. It's saturated with electrons. It's having more than enough. So will it go chasing behind electrons anymore? No. So always in the life also, we like the things that we don't have. Think about it. Even in the normal life, we like the things that we don't have. We usually don't like, we don't have much value on the things that we have already acquired. But the things that we don't have, we love them, we like them so much. So here also, what is coming is electrons. H plus is not having electrons. H plus means no electron at all. Anyway, it is positively charged. So it's suffering from a certain deficiency. Electron deficiency is there. So definitely, H plus is taking the electrons. So 2H plus takes electrons and it's going to H2. So this is the reduction reaction. This is the oxidation reaction. So I will give you a small tip. In your O-level papers, in the galvanic cells, at the cathode, always this is a reduction reaction. Right? For the O-level syllabus only, for the galvanic cells, always at the cathode, hydrogen reduction is there, because in your questions for the galvanic cells, always the electrolyte is H2SO4. Right? So then this is the cell operation there. Then shall we think about the negative positive? Whether this is negative or positive? Then we'll take it like this. Electron flow. If the electron flow is like this, conventional current flow is in the opposite direction. Current is flowing from positive to negative. This is how positive negative coming. Look at the electron flow. Conventional current flow is in the opposite direction. Conventional current is flowing from positive to negative. All right, positive to negative. Then oxidation is always happening at the anode, anox. So oxidation is this. So then in the galvanic cell, anode is negative. This is a reduction. Reduction is happening at the cathode. This is the entire cell setup. In the first statement, tell me whether this explanation is okay. Did you understand it clearly? Yeah, how I got the anode and the cathode here. First, I understood the electron flow. Current flow is opposite to that. Current is going from plus to minus. That I labeled plus minus. Parallelly, I connected oxidation is happening at the anode. Anox. I said in the electrolytic cells or in the galvanic cells, always at the anode oxidation is happening. So then because of this oxidation, I took the anode here. Then this is a reduction, so cathode. Then anode has become negative, cathode has become positive. Okay? Earlier I had got a question asking, is does the electron flow from the external circuit from anode to cathode direction is common to both? All right, I think now I have answered your question. Through this explanation, it is answered. Do electrons move the same way in all reactions? That means in this direction. You mean this direction? If that is what you are telling, no. Now here it is going from zinc to copper because zinc is undergoing oxidation. Right? So zinc is the one who is releasing electrons. So if it is switched, then the electrons are flowing in the other way. Right? Always it's not like that. So electron flow is starting from the one who is undergoing oxidation. If the one who is undergoing oxidation is this one, if it is coming to this side, now I'm not using my hand here because you are seeing it in the opposite way. I'll explain it from the picture. If the one who is undergoing oxidation comes to here, electrons go from here to here. All right. So basically get the idea, electron flow is starting from the one who undergoes oxidation. Okay. Another question, why copper didn't receive? Because it's copper 2 plus. No, this is not copper 2 plus. No, this is elemental copper. This is the copper rod. If you had copper 2 plus in the solution, we would have considered. But it's not copper 2 plus here. This is copper. If copper is accepting electron, it has to go to Cu minus or maybe to Cu2 minus. Such ions are not there, right? These kinds of ions are not there. All right. So we are not at copper 2 plus, we are at copper. Okay. Right. Then we'll go to the next one. Moving. 19. How many electrons, protons, and neutrons are there in calcium 2 plus? So calcium 2 plus, 40 here, 20 here. So this is having proton count 20 because this is symbolizing the number of protons. Because 40 is equal to protons and neutrons. This is protons and neutrons. Since the proton count is 20, neutron is also 20. Electron count, it is 2 plus now. 2 plus means it has released 2 electrons. In the elemental state, electron-proton count is same. Right? In the elemental state, when calcium is not having any charge, 20 electrons are there. Now from that 22 electrons are ejected, it's 18. So the order electrons 18, proton 20, neutron 20. Answer is number 2. Right, that is a simple one. We'll go to 20th. What is the volume of conc HCl? Density is given. Required to form 100 centimeter cube of 0.5 molar dilute HCl solution. So you want to form 100 centimeter cube. Concentration is 0.5 molar HCl solution. To form this one, you are given in the conc HCl solution. I'm asking, what is the volume? What is the volume you have to take from this in order to prepare this? Right. First of all, we'll find the number of moles of HCl we intend to get in here. How many HCl moles do we want? Then volume is there, concentration is there. So I can go with the equation C equals to N over V. I'm looking for N, so concentration times volume. Concentration is 0.5 molar. Volume is 100 times 10 to the power minus 3 decimeter cubes. Sometimes you may be dividing it by 1000. Both of them mean the same thing. And then the number of moles are coming as here. From this, it's 10 to the minus 1 with this 0.05 moles. Thereafter, I'm going to the mass of HCl because now the original data is for the density relating to the given solution. The information we have is the density. Density is mass or volume. So to step on to that one, we will find the mass of this. I said, if you know the number of moles of someone, finding the mass is nothing. So simple M is simple N times capital M, 0.05 moles. Molar mass of HCl is 36.5. When you simplify this, you will get 1.875 grams. Just simplify and see. This is 1.825. So then this is a mass of HCl. All these are going for the HCl. Huh? And then in order to obtain that much of a mass, we have to find what is the volume we need to take from this. Density is mass over volume. Volume is equal to M over D. Mass is 1.825 grams. Density is 1.2. Then volume will come as 1.52, but here I have given it only up to the first decimal point. This is the answer. So first I got the number of moles of HCl. Then I got the mass of that many HCls. Then finally came to the volume. So those are the 3 steps. So there's a question, when using the C equals to N over V formula, why did you multiply with 10 to the power minus 3? There I said, if you multiply this by 10 to the power minus 3 or divide by 1000, maybe you are used to the other way around, you may be dividing this by 1000. Both of them are same, because dividing by 1000 means, so it goes like this, no? Say 1 over 1000. So this is equal to 1 over 10 to the power 3. If you take this 10 to the power 3 to the top, how do you write it? It becomes 10 to the power minus 3, no? So that's what I have written here. Right, I will explain this again. So this is a solution we want to form. Right, this solution we want to form 100 centimeter cubes, 0.5 molar. So then first of all, I found how many HCl molecules do I want? How many HCl molecules in my solution? Concentration 0.5, volume 100. Then I got the number of moles. Then I converted that to the mass of HCl by multiplying the number of moles from the molar mass. Then I got, this is a mass of HCl I want. Right, this is a mass of HCl I want. So to get the mass of this mass of HCl, density is given, right? Density is given. So therefore, we can take mass over volume. So actually, right, when it comes to the questions, there is an additional data given to you because conc HCl is not 100% HCl. It's having a certain percentage, but here I'm assuming concentrated HCl is 100% HCl. So with that assumption only this question is made. So don't worry about that. So after getting the mass of HCl here, right, after getting the mass of HCl here, I'm finding this much of a mass is there inside which volume? This much of a mass is there in which volume? So mass I know, density that is given to me, I was finding the volume. Okay then. Is it clear now? Basically 3 steps. Number of moles, converting that to the mass, relating that to the volume. Right. Then overall tell me whether all the MCQs are clear enough. Did you refresh the theory parts properly? Do you have any doubtful places? Okay, right. Then we'll start the structured essay part. So here, this is very easy. You can help me to fill in the blanks. What is the element with the highest electronegativity? I will be taking the answers that you all are sending me. Quickly tell me. Highest electronegativity, right? Okay, fluorine. Fluorine is the topmost one in the electronegativity scale. Fluorine is the highest. Which group of elements are not having an electronegativity? Very good. That is group 8. Group 8. Third one. From lithium and sodium, who is having the small first ionization energy? Right, okay, that is sodium. The reason for that one is, now I'm asking for the explanation also. In lithium, you have only 2 energy levels. In sodium, you have 3 energy levels. So in lithium, the valence electron is here. This is lithium. This is sodium. In sodium's valence electron is far away to the nucleus. Right? Far away to the nucleus. So when the distance is high, attraction is less. Right? When the distance is high, attraction is less. Then we can easily break the attraction. Right? We can easily break the attraction. So we'll write 2 sentences for that. Say sodium has more energy levels than lithium. Sodium has more energy levels than lithium. Therefore, in sodium, the distance from the nucleus to the valence electron. Therefore, in sodium, distance from the nucleus to the valence electron is high. Therefore, we can easily remove the electron. Right. Then Roman number 4. What is the formula of the chloride formed by aluminium? What is the formula? Aluminium and chlorine. Right. That is AlCl3. How do you get that? Chloride is Cl minus. Aluminium is 3 plus. So you change the numbers. 1 we usually don't write. 3 AlCl3. Right. Electronic configuration of chlorine. What is the electronic configuration of chlorine? Right. It's 287. 2, 8, 7. Then draw the Lewis dot cross structure. So don't draw dot dash structure or only the dot structure. I'm asking for the dot cross structure of the compound you measured in part 4, but that means aluminum chloride. So we'll take it like this. It's having 3 chlorines like this. If you want to use dots to denote the chlorine's electrons, that is all right. But make sure each chlorine is having 3 lone pairs. You can align them like this also. Arrangement is all right. The idea is between each chlorine and aluminum, a single bond is there that should be denoted using a dot and a cross. Around each chlorine, there has to be 3 lone pairs. And essentially, dot cross structure I'm asking for, right? Dot cross structure. Right, moving. Then what is the element that has an allotrope which can conduct electricity? I'm asking for the element, right? I'm asking for the element, right? Carbon, okay. Don't write it as graphite. I'm asking for the element. You can say the elemental symbol or the name of the element, carbon. Write all isotopes of hydrogen in the standard notation that I will write. H11, H12, And then, sorry, here this is wrong. So 2 is at the top, H31. And I will give you an interesting point about this H11 isotope. This is the one and only isotope which is not having even a single neutron, right? This is the only isotope, not only for hydrogen. When you take all the isotopes in the world, H11 isotope is the one without a neutron, because this has one proton. That is what is symbolized here also, 0 neutrons. Right. Part B. So the standard notation means, this is a notation, don't write hydrogen, deuterium, tritium. Those are the names. Where can we find them? They are in the nature now. Out of these 3 isotopes, hydrogen 1,1, if not the normal hydrogen isotope, is the most famous one. This deuterium H12 isotope is less abundant than that. Tritium is extremely less, and tritium is little radioactive also. Right, they are not relevant for the O-level exam. Part B. So natural occurrence is there for all 3. Hydrogen, deuterium, tritium, naturally all 3 are occurring. B. Write a suitable separation technique that can be used in following situations. Right, petroleum from crude oil. What can I use? Very good, fractional distillation. Crude oil is a mixture of lot of components. So from crude oil, we can separate 92 petrol, premium petrol, normal diesel, super diesel, and then kerosene, LP gas. So many fractions are coming out. So this is fractional distillation. To check how many types of colored chemicals are there in a particular ink, what can you do? Oh, very good, chromatography. Right, chromatography. Use by running a certain chromatogram, you can find how many spots are appearing. So the number of spots that you are seeing in the chromatogram, you can relate that to the number of inks, number of types of inks. Right. Third one, to separate potassium nitrate solid from an aqueous solution of potassium nitrate. Vaporization also we can take. Simple distillation. Right, simple distillation. In vaporization is also possible. In the simple distillation, what are the key points I gave you? One volatile component with one non-volatile component. Who is the volatile component here? Water, aqueous solution. Non-volatile component is potassium nitrate. So when you do this simple distillation, water is going out. And finally, you are left with potassium nitrate. So simple distillation O, you can take vaporization. To extract essential oil from plant materials. Right. That is steam distillation. Essential oil is not miscible in water. Essential oil is immiscible in water. They are layering out. Right. Crystallization. You mean for the third one? Yes, crystallization can also be done because potassium nitrate is finally separating out as crystals. That is also involving the removal of the solvent, and then you are concentrating and crystallizing. That's okay. Right. Second structure is a question. The reaction below involves in extraction of iron. What is this Fe2O3? What do you call it? Hematite. Very good. It's hematite. Right. What are the raw materials used in extraction of iron? What are the things you want? Come on. All right. Hematite, coke, and limestone. Very good. Hematite, coke, and limestone. Hematite, if you want, you can write the formula. If not, you can write it in words. Coke and limestone. Limestone means calcium carbonate. Coke means just carbon. Coke means just carbon. Limestone means calcium carbonate. Right. What is the purpose of adding calcium carbonate in the iron extraction process? What is the reason? What is the intention behind we adding calcium carbonate? How can you write it? If I write a simple thing like this, to remove impurities, in the iron ore, does it make sense? To remove impurities? Yes, that is a simple idea. So this answer is enough for the question, but I will just highlight what are the impurities. You can have silicon dioxide, if not simply we say silica, and then aluminum oxide. So to remove these, we are using calcium oxide. This calcium oxide is coming from the thermal decomposition of calcium carbonate. Now limestone is calcium carbonate. When it is heated, calcium oxide is coming. So calcium oxide and SiO2 is getting together. How do you write that? How do you keep that in the mind? Can you notice it's just a matter of you adding all the atoms together. One calcium, one silicon, all together oxygens, 2 and 1, 3. It's just a matter of you adding all the atoms together and writing the formula. There's nothing more. Here also the same thing. Calcium, 2 aluminiums are there. All together 4 oxygens. That's how you write it. You don't have to separately remember the products. It's just a matter of you adding all the atoms together. So this is called the slag. That's how the slag is forming. Right? So the only thing you need to remember is SiO2 and Al2O3. Silica and aluminum trioxide, if not aluminum oxide, simply. Right. Is that understood? The easy way to remember what is inside the slag. Okay. Right. Then when iron is extracted, is Fe undergoing oxidation or reduction? What do you think? What is happening to this Fe here when it is going from here to here? Is it subjected to an oxidation or a reduction? Yes, it's a reduction. Right? It's undergoing a reduction. How do we understand that? Here, now there are several ways of interpreting oxidation and reduction reactions. Here the simple explanation is, at the beginning, Fe is connected to oxygen. Fe is connected to oxygen. If a certain compound is getting rid of oxygen, it's a reduction. That's one interpretation to redox reactions. Right? If someone is releasing oxygen, it is undergoing reduction. If someone is accepting oxygen, that is undergoing oxidation. Right, so this one is reduced. And then we'll take the calculation next. According to the equation given above, to obtain 224 kilograms of Fe, what is the mass of Fe2O3 that should be reacted? So we have to connect one element to another. No? We have to bring a connection between Fe and Fe2O3. So the best way is to travel through the number of moles. That is the best you can do. Right? When you are connecting Fe to Fe2O3, two different things. We cannot directly relate one's mass to another one's mass. Directly we can't relate. Now, example, Fe2O3 to carbon monoxide is in 1:3 ratio. If I say I'm having 10 grams of Fe2O3, I'm asking from you to react with 10 grams of Fe2O3, what is the mass of carbon monoxide I want? In such a situation, you cannot look at this ratio and say, all right, it's 1:3. If I have 10 grams, then this will be 30 grams. This is entirely wrong. Masses cannot be directly related like that. Number of moles is what is directly related. Right? So therefore, you have to relate, you have to convert. If not, you have to take this to number of moles of Fe2O3. Then relate that to number of moles of carbon monoxide, and then come to the mass of carbon monoxide. You have to go through the number of moles. That is a path. So therefore, here also I will take the number of moles of Fe. Now I have the mass of Fe. So NFe is mass over molar mass, 224. I'm converting this to grams, divided by 56. Then this is giving us 400 moles. 400 moles are coming. Then tell me, to obtain this many moles, how many Fe2O3 do I require? Look into the ratio. Fe to Fe2O3. Fe here 2 to 1. Now from Fe I have got 400 moles. What is the Fe2O3 moles I want? Half of that, no? Right? Half of that, no? Right? Now, here what I did was, this is a mass of Fe. 224 kilograms I converted to grams, because the molar mass is coming in grams too. So the equation I'm dealing with is simple N equals to simple M over capital M. So capital M is always coming in grams per mole. Therefore, I can't keep the top one in kilograms. Then convert it to grams by multiplying it from 1000. Then I got the number of moles of Fe. Then I have to relate that to Fe2O3 moles. Right? Number of Fe to Fe2O3 moles. Fe to Fe2O3 is 2:1. Here see, 2:1. There's nothing in front, means 1 is there, no? 2:1. So if I want to get 400 Fe, the amount of Fe2O3 I supposed to have is half of that. Right? 400 by 2, which is 200. Is that clear now? Right. So I have done a small mistake. Thank you for highlighting that. This is not 400, this is 4,000. I have missed 1 0. Thank you very much. So then this is also 4,000 here. Moles. So 4,000 moles divided by 2 is 2,000 moles. The one who didn't understand at the beginning, are you okay now? Have I got the number of moles? Still the question is not finished. So what I did, starting from the mass of Fe, I went to the number of moles of Fe, right? Mass of Fe to number of moles of Fe. Then using that, we came to number of moles of Fe2O3. I said you cannot directly relate the masses. You have to go through the number of moles. So this fellow's mass to that one's number of moles. Then that one's number of moles, we are relating that to the other person's number of moles. Because number of moles to number of moles, we can connect. All right. Then we can convert this to its mass. Then mass of Fe2O3 will be 2000 moles by Fe2O3's molar mass is 5648. Is it 150? Have I done a mistake? Check on that quickly. Is the number correct? Very good. It's wrong. It is 160. So stay alert. It's 160. So multiply this by 160 grams per mole. So then the mass should be coming as, I'll directly keep it in kilograms, 320 kilograms. 320 kilograms. So finally, we have come to the mass of Fe2O3. See, I went through the number of moles. We started from here. Mass of Fe. Mass of Fe cannot be directly related to mass of Fe2O3 because masses are not directly relatable. We have to go through the number of moles. See, mass of Fe2, moles of Fe, that to the other person's number of moles, then finally we are in the mass. Is that concept understood? Can you see the roadmap clearly? Okay. Didn't get it? Right. So the basic point is mass to mass, you can't directly convert or else you can't directly connect. Always go through the number of moles. Right. Fifth one. Miss, from where do we get this 160? Oh, that I got from the relative atomic masses. 56, oxygen 16. So then this is the molar mass of Fe2O3. See grams per mole. Fine. That is a molar mass of Fe2O3. Right. Moving to the fifth one. In order to obtain 12 moles of CO2, how many moles of Fe2O3 should react? Now again we have to now understand this number of moles to number of moles. You can directly relate. Number of moles to number of moles you can directly relate. Mass to mass is what you cannot relate directly. So then we'll take the ratio here. CO2 to, should I take it here? Then it's more spacious. CO2 to Fe2O3. I'll look at the equation at the top. CO2 to Fe2O3. See, CO2 to Fe2O3. 3 to 1. 3 is coming under CO2. See, 3 is to 1. Then how many moles are we getting from CO2? 12. Then tell me how many Fe2O3 should be reacting. So what is the relationship you are seeing here? 3 is to 1 means Fe2O3 is 1/3 of CO2. Then here also we need to take 1/3. 1/3 means 12 moles divided by 3. That is equal to 4 moles. So this is 4 moles here. That is a simple question. Right, part B. What is the mass of NaCl required to prepare 200 centimeter cube of 0.1 molar NaCl? This is volume, this is concentration. I'm asking for mass. So first, by relating these two, we can get N. And I said, if you know the number of moles of anyone, it's nothing for you to convert that to its mass. Then I'll first take the number of moles. N is equal to C times V. Concentration is 0.1 molar times 200 times 10 to the power minus 3 decimeter cubes. Then the number of moles are coming as 0.02. Then I'm relating this to the mass. Simple M is equal to simple N times capital M. 0.02 moles times smaller mass is, here again I will give you the information. Sodium is 23, chlorine is 35.5. Chlorine is 35.5. Then this is coming as 58.5 grams per mole. So when you simplify, this will be 1.17 grams. So here also first we are taking the number of moles, then we are relating that to the mass. Right. Is that question clear? So these calculation questions are going with a small map, right? They are going with a small map. So always look to see what are the information given to you and what are they asking. So volume is there, concentration is there, and finally they're asking for the mass. So directly we can come through number of moles, because C and V is there means obviously it's ringing a bell in the head that we should be going to N. You know N means getting M is nothing. Right. The next one. Clearly mention the steps you would follow to prepare the NaCl solution mentioned in part B above, the previous one. What are the steps you have to follow? Altogether, there are 4 things you need to do. First step is you have to measure the required mass of NaCl using the triple beam balance. Right, that is a first step. Measure the, if not, you can say 1.17 grams of sodium chloride. If not, you can say required amount of sodium chloride. Measure it using the triple beam balance. Second point, now we want 100 centimeter cubes. Sorry, we want 200 centimeter cubes. Right? The solution, we want 200 centimeter cubes. Therefore, next point is put the measured mass into a 200 centimeter cube volumetric flask. Put the measured mass into a 200 centimeter cube volumetric flask. Third point, dissolve the sodium chloride mass in small amount of water. Dissolve the sodium chloride mass in small amount of water. Finally, only we are topping it up. So then write, add distilled water up to the 200 centimeter cube mark. Add distilled water up to the 200 centimeter cube mark and shake well. So those are the 4 steps expected from you in the exam also. Are the steps clear? Do you want me to repeat anything? Yeah, sure. I'll repeat the statements. First one I said, measure the required mass of NaCl using the triple beam balance. Second one, put the measured mass into a 200 centimeter cube volumetric flask. Third one, dissolve the sodium chloride mass in a small amount of water. Last step, add distilled water up to the 200 centimeter cube mark and shake well. Second statement, what I said was, put the sodium chloride into 200 centimeter cube volumetric flask. That is the second statement. Put the sodium chloride mass into 200 centimeter cube volumetric flask, because the solution we want to prepare is 200 centimeter cubes. Right. Then part C, write the balanced equation for the reaction between sodium hydroxide and HCl. That's easy, eh? Sodium hydroxide HCl, you are forming NaCl and water. Now you can tell me what type of a reaction is that? Answer has already reached me. Very good. So this is a neutralization reaction. Right? Neutralization reaction, because acid and a base are reacting together. So not the exothermic reaction. No? I'm asking for the type of the reaction. No? So then the best answer says it's a neutralization reaction. Right. Third one, when that reaction is taking place, what is the observation you may notice? And explain the reason for it. What could be the observation? What could be the observation? Observation is temperature is increased. That is how you should be answering that. Right? Temperature is increasing. Observation means something we see or something we feel. If there's a color change happening, we can see it. If heat is liberating, the observation is not that the solution, if not the reaction is releasing heat. Observation is what we feel is the temperature is rising. Right? Temperature is rising. Then the reason for the observation is, if not how we can explain the observation is, neutralization reactions are exothermic. Neutralization reactions are exothermic, therefore they release energy. If not, they release heat. The simple point is neutralization reactions are exothermic. For this one, double displacement is not the reaction type, it has to be the neutralization. Because acid and a base is reacting, no? So then it's particularly falling under neutralization. Double displacement you can take if two salts are reacting, then double displacement is working. But here it's particularly an acid and a base. Right. Then explanation, I hope it's clear. Neutralization reactions are exothermic. Further, if you want, you can write, therefore, heat is given out. Heat is given out. Right. Then we'll take the next essay question. Structured essays are over. Are there any questions from those? Anything which is not understood properly? No, right? Right. Then we'll take the essay questions. So this is a picture showing a signal tower made up of iron, which is set up in the middle of a small tank. First, I'm asking, what are the factors required for the corrosion of iron? What are the factors? First one, come on. What are the factors you want in order to observe the corrosion? Yes, moisture. So that means H2OG. If not, you can say moisture. Other one? Apart from water, what do you want? Apart from water? So I'll just keep it as water there generally. Now, oxygen, right? From air, particularly oxygen is required. Second one, out of the three parts labeled above, which part can undergo corrosion easily? What is the part? The part exposed to the atmosphere or inside water or underground? What do you think? So here, better you take the part which is exposed to the atmosphere. The reason is the part which is exposed to the atmosphere is getting oxygen and moisture, both of them, right? Atmosphere, the part exposed to the atmosphere is getting oxygen and moisture, both of them. All right. Now, inside water also corrosion is happening, but inside water, the amount of oxygen is limited, right? Amount of oxygen is limited. So when it comes to the part exposed to the atmosphere, oxygen is not limited and the moisture is also not limited. So therefore, we'll go with the part exposed to the atmosphere. Right, because both the conditions are, it's getting both the conditions in ample amount. Write the reaction that takes place when iron undergoes corrosion. What is happening to iron? what is the reaction happening with respect to iron? Fe is going to which ion? We'll write the reaction there. Yeah, it's undergoing oxidation. It goes to Fe2 plus and 2 electrons. That is what is happening to iron when it is undergoing corrosion. Then out of the 3 parts labeled above, which part has the least chance to undergo corrosion? Least chance is there for the underground part, because beneath the ground, right, moisture and oxygen, both of them are limited, extremely limited, especially oxygen. Oxygen is very much limited underground. Fifth one, in order to protect the tower from corrosion, engineers have decided to connect a block of another metal to this tower. Suggest a suitable metal for this task out of the 3 given below. Which one would do the job? Lead or zinc or copper? Yes, it is zinc, not copper. Huh? Few of you are telling copper. No. It has to be a certain element which is found above iron in the reactivity series, right? Above iron in the reactivity series. So if you see them in the order, zinc is at the top, then you get Fe, and then comes lead, and then the hydrogen is there, copper is even below hydrogen. So the one which is at the top of Fe is zinc. So we have to choose zinc here, because the idea there is, if you want to protect your iron, from what are we trying to protect iron? We want to protect iron from undergoing oxidation, if not undergoing corrosion. Iron corrosion means iron is undergoing oxidation. So simply we want to prevent iron's oxidation. So if you want to prevent iron's oxidation, we have to select a metal who can undergo oxidation better than iron. Right? We want to select a metal who can undergo oxidation better than iron. Then that element is the one who is found above iron in the activity series. That is zinc. Right. 6.1. When the above mentioned metal is connected to the tower, state how it can prevent the tower from undergoing corrosion. So simply we can say that metal will undergo oxidation in place of iron. That metal will undergo oxidation in place of iron. Yes, it is acting as a sacrificial substance. Correct. Sacrificial protection is that. All right, anodic protection is also the same thing. Anodic protection, that is not the anodic protection. The anodic protection means Fe is selected as the anode. Oh, how have you learned the anodic protection? In the anodic protection, which one is taken as the anode? Iron or the other metal? Which one have you taken? Zinc? Is that particularly for this situation? So anyway, now when you are connecting zinc is acting as the anode, because always oxidation is happening at the anode, no? Right? Whatever the reaction, whatever the cell type, now in the corrosion also small electrochemical cell is working. So then the oxidation is happening at the anode. So then here zinc is acting as the anode, and our Fe is becoming the cathode. Right? Fe is becoming the cathode. So on the Fe surface, the reduction reaction is happening with respect to oxygen actually. So here the simple idea is how our metal is protecting the signal tower is in place of iron. that is undergoing oxidation. Therefore, our iron is protected. So that is a sacrificial protection if not. B. K, L and M are three types of solvents. A student sketch the spread of the components when they are mixed together. Right, you can help me now. What is a homogeneous mixture, P or Q? Right, it's P. Right, it's P. How do you identify that? Second one I'm asking. Briefly explain the reason for you to choose that mixture as a homogeneous mixture. How do you say that in a simple language? So throughout the solution, right? Throughout the solution, composition is same. If not, you can say throughout the solution, composition is uniform. Right? Composition is uniform. Right. Third one. Iodine is well dissolved in solvent K and slightly soluble in solvent L. What can you say about the polarity of those two solvents? Right? Polarity of those two solvents. Right? What can you understand about the polarity of solvent K if iodine is perfectly soluble in solvent K? Now, iodine is soluble in solvent K. So what can you say about the polarity of K? Now, iodine is nonpolar. If iodine is soluble in a certain solvent, well, that means that solvent is also nonpolar because like dissolves in like, no? Right? Like dissolves in like. So then K is nonpolar. And in L, iodine is slightly soluble. Right? Sorry, in L, in solvent L, iodine is slightly soluble. So then solvent L will be polar. Now iodine is always non-polar. So it is preferentially getting soluble only in non-polar solvents. When it comes to a polar solvent, it is not that soluble. What is this? How do we know that? The fact that I2 is non-polar. I2 is non-polar because it's iodine and iodine here. So there's no electronegativity difference. So it's a perfectly non-polar bond. All right. And then here I said iodine is well dissolved in solvent K. If iodine is nonpolar, it is well soluble in nonpolar solvents. So therefore solvent K is nonpolar. All right. So then if the nonpolar iodine is slightly soluble in solvent A because the polarity is not compatible, then it is polar. Right. And then based on the above question, what could be said about the polarity of solvent M? Then so far we know solvent K, this is non-polar. Solvent L is polar. And here L and M, they have formed a homogeneous solution. Then what can you say about the polarity of M? M is polar, right? M is polar. Because we already know that L is polar. So M is forming a homogeneous solution with L. That is because M is polar. M's polarity is compatible with L's polarity. Compatible means same. It's polar. Right. Then I'm asking, if the three solvents used in this activity are water, thinner, and alcohol, how would you match them to solvent K, L, and M? How do you match it? Now we'll start from L and M. L and M, both of them are polar. Right? Both of them are polar. L polar, M polar. Then from water, thinner, and alcohol, water and alcohol are polar, right? Thinner is an organic solvent, no? Right? Thinner is an organic solvent. So therefore, thinner is non-polar. Then I can say K is thinner. Right? K is thinner. Agree with me? All right. The entire answer I received. Very correct. So then, if you think about thinner and this other layer, L, now we have water and alcohol. Out of water and alcohol, water is more polar than alcohol. Water is more polar than alcohol. So then we better assign water here. Out of alcohol and water also, water is more polar. Then M is going to alcohol. Alcohol is organic, but it has a polarity. Right. Is that question understood? Right. Okay. Then we'll go to the next part. Hydrocarbons. There's a question now, all organic compounds non-polar? No. There are some polar organic compounds, but majority of the organic compounds are non-polar, but not all. Right. Quickly try on the answer for this one. I'll be back in a minute. Continue. Right. Okay. So there's another concern I have to clarify related to the this one, the previous question. When it comes to the signal tower question, at the end, I have been asking from lead, zinc, and copper, which one is suitable in protecting this one. And again, a question is there whether this is cathodic protection or anodic protection. So here I said the metal you are connecting is undergoing oxidation, thereby our iron is acting as a cathode. No, on the iron surface, cathode reaction is happening. So therefore, that is a cathodic protection. All right. Cathodic protection, if you want the name, if not sacrificial protection. And the thing that is happening inside is the metal block you are connecting is undergoing oxidation in place of iron. Is that doubt clear now? Okay. Right. Fine. Then we'll take this one. What is a hydrocarbon? Hydrocarbon is a compound containing only, right? Only word is essential there, only carbon and hydrogen. Right? Only carbon and hydrogen. Then formula of the alkane having 3 carbon atoms. Can I know the formula there? With 3 carbon atoms. Quickly send me the formula. Right. Very good. So that is C3H8. C3H8. The general formula of an alkane is CnH2n plus 2. No? Whatever the number of carbons you have here, when you are relating that to the hydrogen atoms, 2n. Now here number of carbon is 3. 3 times 2 is 6. 6 plus 2 is 8. So it is C3H8. Then the balanced equation for the complete combustion of the above mentioned hydrocarbon. C3H8 with oxygen, all the carbons are coming to CO2. So 3 CO2s are coming because 3 carbons are there. And hydrogens, 8 hydrogens are there. Therefore 4H2O. To balance oxygen, here 6, 4 altogether 10. Therefore 5 O2 coming here. Right. Then we'll take the last essay question. Is the first essay question completely all right? Are there any doubts related to the anodic protection, cathodic protection, those words, or the corrosion of iron? Any concern at all? Seems like no, eh? Right. I'll take the last one. The student did an experiment using 3 metals X, Y, and Z. So they are not having the actual symbols. And I'm telling when X, Y, and Z are placed in 3 separate test tubes with heated distilled water, only the test tube with metal Y liberated gas bubbles. Small adjustment was done to this question. Please add this statement to your paper. However, metal Y doesn't give any observation with cold water. That is a newly added part. Right? So take this in. However, metal Y doesn't give any observation with cold water. Can you suspect who this Y is here? Any idea? The metal who cannot react with cold water but can react with hot water. All right, very good. So here our Y is magnesium. Further, I'm telling when metal X and Z are added into dilute sulfuric, only X was dissolved by liberating a gas. So seems like Z is not reacting even with the acid. Y reacted with the water. If someone can react with the water, definitely it can react with the acid. That is not questionable, right? If someone can react with water, it can definitely react with acid because acids are more powerful than the water, right? But in here, in the second one, when you add the acid from X and Z, only X is reacting, still Z is not reacting. Right. Then tell me what is the gas coming out from the test tube with metal Y? What is the gas? Now, actually, you know who this Y is. When magnesium is reacting with water, what is the reaction? Magnesium with water. This is forming magnesium hydroxide and hydrogen. So the gas is hydrogen. Out of the 3 metals, X, Y, and Z, which metal is found at the top of the activity series? The most active one. Top of the activity series means most active one. Who is at the top? X or Z or Y? Y, yes, it's Y. So the reason is, now we are reacting these metals with water and with acid. So Y is reacting with water means it is obviously reacting with the acid. That is not a question. That information, we don't have to give that information to you. That is understood. If someone can react with water, acid is nothing. Acid is nothing for him. And then when you take X, X cannot react with water. Now if I put a small chart here, Y, X and Z with water and with acid. This is reacting with water and with hot water it's reacting. With acid, obviously it is reacting. We don't want extra information for that. Understood. X, this is not reacting with water, but it's reacting with acid. Z, nothing. Then the one at the top of the activity series means the most active one. That is Y. Who is the one found at the bottom of the series? Z. That is the least active one. Right? Least active one. Least active one is the one who is not undergoing reactions with any of these. Right. From the above three metals, which one is burning with a bright flame? So by now we know who is this Y. That is magnesium. When magnesium is burning, it's burning with a bright white flame. Right? It's burning with a bright white flame. So therefore, this is metal Y. And then what is the color change occurring with blue litmus and red litmus when they are added to a solution carrying the residue of the above mentioned combustion? Now, when magnesium is combusting, what is happening? It is going to MgO. So when you add this into a solution, this is forming magnesium hydroxide now. So magnesium hydroxide is there means OH minuses are there. When OH minuses are there, solution is basic, right? Solution is basic. So red litmus, what will happen to red litmus in a basic solution? Red litmus is turning to blue. When you add blue litmus to a basic solution, you are adding blue litmus. What would happen? It remains same. No, it's not going to pink. It is remaining same. Bases are not showing any color change with blue litmus. Here, no change. If not, you can say blue color is remaining. Right. So this is a reaction for the combustion. The residue is magnesium oxide. When you add that into water, magnesium hydroxide is coming. Additionally, I showed the reactions also. Then fifth one, what is the reason for that color change? So we can simply say, because of the OH minus ions, medium is basic. Because of the OH minus ions, medium is basic. Right. And then here also, please change your, I think in your one, you are saying this one as X, change this to Y. There are 4 places you have to change. If the metal Y is found within the first 20 elements in the periodic table, and the sulfate of Y is YSO4, what could be the actual symbol of metal Y? That is magnesium. Without any of this information, you can understand it's magnesium, because at the top I said it is not reacting with cold water, but with hot water it can react. That is a significant feature of magnesium. Right, we'll go to the next part. What is a polymer? How would you define the word polymer? Polymer means it's a large molecule. That's one point. Polymers are large. We never get tiny, tiny, small polymers. No, polymers are always large. So it's a large molecule formed from the combination of, right? It's a large molecule formed from the combination of large number of small molecules, right? Large number of small molecules. So you have to emphasize the fact that polymers are large, if not big. And then it's coming as a combination of large number of small molecules. Again, we are emphasizing large number of small molecules. Right. Then we have to fill in the table. Polythene, monomer. That's a very famous monomer. What do you call the monomer? What is the name of this monomer? What is this? Ethene, right? It is ethene. All right, ethene. Okay. So then you have to know the monomer of polythene because it's very simple. Polythene, the monomer is ethene. Repeating unit is you are removing this double bond. Two hydrogens are connected. And it's having two single bonds again. Polymer means this repeating unit. Repeating unit is getting repeated for n many times. It's getting repeated for n many times. So you take the repeating unit, put a bracket. We usually go with a square bracket and write n outside. That is the only difference between the repeating unit and the polymer. Repeating unit, you write, put the bracket and put n. PVC again, we are releasing this double bond. And there is a chlorine. So carefully write it. Here also the same thing. We take the repeating unit, put a bracket and write n. Then for this one, I have given you the repeating unit. Then when you are writing the polymer, that is very easy. Repeating unit, n times repeating. Monomer is, we will be placing a double bond. Right, is that refreshed now? Polythene monomer is ethene, and the simple connection between the repeating unit and the polymer. All good? Right, then I'm taking part C. Consider the reaction between granules of calcium carbonate and hydrochloric acid at 25. Balanced chemical reaction. So first one I'm writing here, calcium carbonate. This is requiring 2 HCl. This is going to calcium chloride, CO2 and water. Second one, how would you identify the gas coming out of this reaction? So the gas is CO2. We have to identify CO2. So the identification test of CO2 is when you bubble CO2 into clear lime water solution. Right? It has to be a clear lime water solution. Upon bubbling of CO2, lime water solution is turning milky. That's a famous test. So you bubble the gas into clear lime water solution. Then lime water solution will turn milky. That is how you identify CO2. So definitely clear lime water solution. Huh? Clear lime water solution, that word is essential. Third one, if you wish to accelerate the rate of this reaction, what are the things you can do? What kind of things you want to accelerate the reaction? Tell me one. Increase in the temperature, okay, I accept it. Increase in the temperature. Another one, using a catalyst. All right, but for this acid-base reactions, now calcium carbonate and HCl reaction is also an acid-base reaction, neutralization reaction. So therefore, for such reactions, we usually don't use catalysts. One sensible answer will be, we can use powdered calcium carbonate. Instead of using granules, we can use powdered calcium carbonate. And another thing, now I'm asking for two only, but I'll write this third one. You can increase the concentration of HCl. You can increase the concentration of HCl. So those are the three sensible things you can alter. Catalysts, for most of the reactions, catalysts are working, but calcium carbonate HCl reaction, we don't put a catalyst for that reaction. Right. Explain how those changes can increase the rate of the reaction. When you increase the temperature, rate is increasing. How is that? Basically, when the temperature is high, molecules are more active. They are moving a lot. So whether you increase the temperature or whether you convert these granules to powdered calcium carbonate, or whether you increase the concentration of HCl, from all those three, what we are facilitating is more number of collisions, right? More number of collisions. So more number of collisions is what is leading to a high reaction rate, right? Number of collisions are increased. Number of collisions, particularly telling number of collisions taking place within a unit amount of time, because you have to pay attention to rate, no? Number of collisions taking place within a unit amount of time is increased. So thereby reaction rate is increased. Right. Okay. You're asking for O levels. What are the catalysts you should know, and what are the reactions they are used? For your O levels, there's no any catalyst list as such, but I can generally tell you for acid-base reactions, we don't put catalysts, right? Acid-base reactions, we don't put catalysts. What is the question? Second question answer means which part of the second question you want me to repeat? Which part? Second question. C Roman number 2. How would you identify this gas coming out? So you can direct the gas into a clear lime water solution. Lime water means calcium hydroxide. You can direct the gas. If not, you can bubble the gas into a clear lime water solution. If the clear solution is becoming milky or turbid, the gas is CO2. Okay. To a clear lime water solution, bubble the gas. If the clear solution is turning to a turbid or a milky solution, then the gas is CO2. Understood? Right. Okay, that question. Fine. Then this marks the end of the question discussion session. Then finally, the only thing I have to tell you is O-levels is not a huge exam, but it's very, very important, especially when it comes to you selecting the A-level subjects. O-level exam is playing a crucial role. Because last time also in the A-level batch, I have some experiences related to some students. They wanted to do biology or maths for their A-levels. They started doing the A-levels in biology stream or the math stream, but halfway they had to change it to other streams because their O-level results were not that good. So therefore, O-levels is not the hardest exam in the world or in Sri Lanka, obviously. So particularly that will be A-levels, but O-levels is very, very important in so many aspects. One I highlighted, especially when you are choosing the A-level subjects. So if you, whether you are intending to do science subjects or not, try your level best to complete all the O-level papers in a nice way. And a very limited amount of days are there. So amidst all these problems in the country situation is not good, but understand one day everything will be coming back to normal, because Sri Lanka is not going to remain in the same situation for years and years. It will be definitely getting better, right? Even in a slow rate, it will be definitely getting better. So you have a certain responsibility from your side. Just imagine the day that the country is getting back to normal. You have to make sure you have done a good thing to yourself, right? A good thing to your life. So one day country is getting good. So on that particular day, you should have made and achieved all the education qualifications and the required experience around you, because ultimately only you can protect yourself. All right, only you can protect yourself. So the biggest barrier, the biggest protection that you can ever have for your life is the education, right? So when it comes to all the job fields that are available in the world and the country now, the jobs related to the educational field, or else the jobs that the educated people can get, those jobs are the jobs with the least risk. So therefore, don't get caught by different stories that is moving here and there in the social media, especially related to cryptocurrencies. And then when it comes to things like drop shipping, doing this online business, that online business, so many stories are there in the especially in the YouTube, I have noticed. So for your age, there is a high risk that you will get caught by those fancy stories. Understand, those types of stories are there in the world, that is true, but number of such stories are very limited. Unfortunately, what happens, those limited number of stories are getting a big famous, right? They are catching a big fame. So therefore those stories are getting distributed everywhere. So don't allow those types of stories to ruin your education. So complete the O levels in a good way, and then complete A levels also in a successful way. And finally, try to secure a nice position in a reputed university. Right. Then finally, all the very best, not just for your O levels, for the entire life. Good night. I'll call upon Jagat sir.
Right. Okay, dear students, we had a very good session today with Ms. Madhu Haputantri. This is the third consecutive seminar I conducted for this time O-level batch, and I think definitely today the chemistry session, so it will really help to to improve your results. And if you have any doubts, you can ask through the chat even now. And if any one of you to listen to this again, you can request a recording after the seminar. And once again, I would like to thank Ms. Madhu Haputantri for sharing your valuable time today. And
Sure.
and definitely, if any one of you are planning to do A-level bioscience maths, you can join with for chemistry English medium from June, and we'll pass the information after your results, after your exam. I think you exam is scheduled from 23rd of May until 1st of June. And first focus on and do your best. And definitely, all the students, I wish all the very best for the exam. And with the today's seminar, I think this time oral batch also I'm finishing all the classes. But anyway, if anyone of you have registered already for this tomorrow morning paper class, you can join with that. So thank you very much, Miss Madhu, and God bless you, and thanks for sharing your very valuable time today and your advice for all the students for this time oral batch.
Right. I'm happy to help.
So there are a few minutes left, so I will move it to the other paper. I have shared two more papers. I have shared two papers with you, and
Then
one
I'll
paper.
take my leave, sir.
Sorry, yeah,
I'll take my leave.
yeah, sure, yeah. Thank you very much.
Okay.
Welcome. Good night.
Good night.
Right. So you can see the screen now. I will highlight. There are a few more questions I have to highlight in the other paper. I don't think I have time to discuss all those questions. There are some areas where you always get questions in the paper from this chemistry part. One part is this grade 10 chapter 16 gas production. You can get the questions from this gas production and gas preparation, identification, experimental setup, production of oxygen, hydrogen and carbon dioxide. They will never ask you to draw this entire setup. Mostly you get the experimental setup. Sometimes they can give this one example, you can see the screen, with defects. And they'll ask you to identify what are the defects in the setup and to make the correction. Therefore, you have to pay attention to those experimental setup, especially labeling, grade 10 chapter 16 gas production, and experiments under rate of reactions. You can get structured essay type questions or even essay type questions. Grade 10 the most important part. And grade 11, I think you had many questions to be in today's seminar. That is especially electrochemistry, hydrocarbon lesson, and questions based on the activity series. Activity series grade 10 chapter 16, again you have to remember all 14 metals, otherwise you will find many chemistry questions to answer. You find it difficult to answer many chemistry questions. And other than that, you have to study under chemical industries, grade 10 iron extraction blast furnace, grade 11 chapter 3 under separation techniques, solid extraction, chromatography, fractional distillation, steam distillation. Fractional distillation actually last year they asked. Steam distillation and simple distillation experimental setup. Then chromatography very important this time. And grade 11 electrochemistry, hydrocarbons, and chapters 7 and 8 acid base and heat changes associated with chemical reaction, energy level diagram, especially exothermic and endothermic reaction is not a very lengthy lesson. Content is less, but it's important for the oral exam. Because anyway, the chemistry part you get around 12 to 13 MCQs as I explained today from the beginning. And essay type questions you are getting question number 6 and 9A. Structured essay question number 3 from completely from chemistry. So So there's a question like, what is a control experiment? Yes. Now, actually, control experiment means you have in a scientific experiment, to make it a fair test, you need experimental setup and control experiment. Even you can explore and search in the internet variable factors, control variable, and if you take many experiment, even biology, photosynthesis, so you provide all the other factors except the selected factor for the experimental setup. Control experiment, you provide, including the factor that we select, we provide all the other factors. That is to compare our results. Without a control experiment, we cannot come to a proper conclusion. So that is the question you raise. Now, this question you can see the screen. Write 2 errors that can be seen in this setup. Very important, even biology also, you get under respiration. There's an experiment under respiration in grade 10 chapter 8. There are 2 experiments under respiration. So they are also the experimental setup. They can ask questions like this. Right now, what one error you can see, if you keep like this the funnel, gas can leak to the outside. What is the gas produced here? Hydrogen gas. If you add a metal, if you add an acid to a metal, what is the gas coming out? Hydrogen gas. But all the metals not going to react with, especially dilute hydrochloric acid doesn't react with the metals below copper in the activity series. Copper and any metal below copper, they don't react with dilute acid. But zinc, magnesium and all the other metals above hydrogen in the activity series react with HCl, liberating hydrogen gas. So what happens here, the gas can, when once HCl is completely added from the funnel, gas can come out instead of passing through the delivery tube. That is one issue. That means the defect. If they ask the error, you have to write the error, not the correction. So the error here, this will funnel the tube, it doesn't contact with the solution. That is one error. Second error, the method of collecting this gas. What is the gas coming out? Hydrogen. You can't collect hydrogen by this method, because hydrogen is lighter than air, less denser than air. Hydrogen gas you have to collect by downward displacement of air, because hydrogen is any light gas, lighter than air. So when the gas is collected here, atmospheric air get displaced downwards. This is called downward displacement of air. Lighter gases should be has to be collected like this. Now this method is good for collecting CO2 gas. Right now, so what is the one error? So I'll write here number 1. This is the error. The funnel, end of the thistle funnel doesn't contact with the solution. OSE. Number 2, wrong method of collecting the gas. Keeping the gas jar upright. You have to keep this gas jar inverted. How to make the correction? By keeping the gas jar upside down or inverted. So those are the 2 errors. I put 1 and 2. So sometimes they will ask you to make the correction again. Number 2, suggest 2 measures that can be adopted to increase the rate of reaction taking place in this particular class. To increase the rate of reaction, you can use zinc in the powdered form. They use granules. You can use in the powdered form. That is one change you can do. using zinc in the powdered form instead of granules. Second method of increasing the rate, you can increase the concentration of hydrochloric acid by increasing the concentration of hydrochloric acid, or by increasing the surface area of zinc granules. How to increase the surface area of zinc? By converting that into the powdered form. If someone write by increasing the temperature, if you are heating this also, the reaction will increase the rate. But acid metal reactions, so normally we don't use catalyst. But if we can use a catalyst, that is better. There are mainly catalysts. We have nickel, iron catalyst in your syllabus, platinum, and vanadium pentoxide V2O5. These are the 5 catalysts given in your syllabus. Platinum, nickel, iron catalyst, and vanadium pentoxide V2O5. So mostly in nitric acid industry, we use platinum catalyst. Nickel, hydrogenation of catalytic hydrogenation, we use nickel catalyst. Margarine production. Iron catalyst, production of ammonia by Haber process, is given in grade 10. And vanadium pentoxide, that is for manufacturing sulfuric acid, battery acid. V2O5 is used as a catalyst. Now, for all the chemical reactions in the world, we can find catalyst. Catalyst not available for all the chemical reactions. If catalyst is available for a chemical reaction, that is the best method to increase the rate. By catalyst, no need any fuel cost. When you increase the temperature, there will be a fuel cost. There will be an environmental pollution. Energy cost will be high. Price of the product increase when you are increasing the temperature. Instead of increasing the temperature, catalyst, if you can use, that is the best method of increasing the rate. They can ask that question in the exam. Advantages of using catalyst instead of increasing the temperature. Catalyst can increase the rate at normal temperature, at room temperature. Therefore, no energy cost, less environmental pollution. And the other one, catalyst not required in large amount. Fuel you have to continuously burn, higher energy cost. And catalyst can be reused. So therefore scientists, they are doing research for industrial productions. There's a continuous improvement of that production process by introducing catalyst. Number 3, test that can relevant to the observation to confirm that the gas produced is hydrogen. So you can identify the gas produced if you introduce a lighted alkyl into the tube containing hydrogen gas. What happens? It burns with lighted alkyl, burns with pop sound. Gas burns with pop sound. Hydrogen gas burns with pop sound. That is the answer for the last one. That is the test. And you have to write the observation also. The test also you have to write. The observation also you have to write. Right. So this one I took this question, this experimental setup, because you have to refer the others also. Carbon dioxide production experimental setup, and oxygen production experimental setup, and method of collecting. So basically the gases, these are the 5 things you should know. Number 1, you should know how to produce the gas, method of producing the gas. Number 2, method of collecting the gas. Number 3, method of identifying the gas. Identification, production, collection, identification. Number 4, properties of the gas. Number 5, uses of that gas. What are the 3 gases you should know? The production, collection, identification, properties and uses. Hydrogen you should know. Carbon dioxide you should know. Oxygen you should know. Other than these 3 gases, there are 2 other gases you should know a little bit in detail. That is nitrogen gas. Nitrogen gas also you should know. Uses of nitrogen, properties of nitrogen. But production of nitrogen not necessary much. Large scale we can produce nitrogen from the atmosphere because 78% nitrogen in the atmosphere, fractional distillation of liquid air. Oxygen also we can use the same method. Grade 10 we use CONDIS, potassium permanganate, hydrogen peroxide, potassium chloride, potassium nitrate for the oxygen production. But oxygen can be produced in large scale by fractional distillation because 21% by volume oxygen in the atmosphere. Fractional distillation, what are the 2 gases can be produced or extracted by fractional distillation? oxygen gas and nitrogen gas. What is the natural resource? Atmospheric air. That you have to remember. But global oxygen production, not any of this. That is photosynthesis. Okay. Then at the beginning of this paper, there are a few MCQs I have to discuss. Look at the screen. What is the color of the pinophthalene? Indicators, you should know the color change in the basic medium. Basic medium means hydroxide ion containing medium, more hydroxide. Remember, in a medium, if H plus ion concentration equal to OH minus in a medium, that is called neutral. Example, water. Water undergoes self-ionization, auto-ionization, producing H plus and OH minus. But what is neutral? Because H plus ion concentration equal to OH minus ion concentration. If you take 100% pure water even, it slightly ionized like this. That is not an acid, but it produces equal amount of H plus and OH minus. Therefore, what is neutral? Number 2, if H plus ion concentration is greater than OH minus, then we call it acidic. H plus ion concentration more than OH minus, acidic. If H plus ion concentration, if OH minus ion concentration greater than H plus, that is basic medium. Therefore, medium become acidic or basic based on this. If concentration of these two equal, neutral. Number 1. Number 2, if H plus ion concentration greater than OH minus, that is acidic medium. How to identify? Because not visible to our naked eye, H plus or OH minus. If they are visible to our naked eye, we don't need any indicators. We can directly tell this medium contain more H plus, therefore acidic. But since it is not visible to our naked eye, we use indicators. Pinophthalene indicator used to identify OH minus, hydroxide or basic medium. Example, sodium hydroxide. Even in rustin, this is widely used. In rustin, one reaction is what? H2O and O2 combine to become with electrons forming OH minus, hydroxide ions. 2H2O plus O2, you get 4OH minus. By gaining electrons, this is a reduction reaction. Therefore, in electrolysis, electroplating, now even in rustin, electrochemical cell, you can identify the place where the OH minus produced using pinophthalene indicator. Even in rustin, you can identify this. Bases can be identified using pinophthalene. What is the color? Pink. But once in the oral paper they gave this question, they accepted red also. Pinophthalene, what is the original color of pinophthalene? Colorless. With bases it turns pink. Answer is second. Question number 2. What is the acid that is used for the coagulation of rubber latex? Weak acid. Rubber industry, we use two chemical substances. One is ammonium solution, ammonium hydroxide, that is anticoagulant, and coagulant will be the weak acid, CH3COOH, acetic acid. Answer is third. Actually, the other acid also bit important. You should know what is H2SO4 battery acid. Sulfuric acid. What is the catalyst used? Vanadium pentoxide in the manufacturing of sulfuric acid, battery acid. Hydrochloric acid present in your stomach also. Both these are strong acid. Nitric also is strong acid. They completely ionize. pH value is very low. But vinegar. So what are the other names given for this? Acetic acid. Acetic acid. Acetobacter bacteria. Vinegar industry. Acetic acid. That is also called sometimes ethanoic acid. Ethanoic acid. Eth means 2 carbon. Ethanol, ethanoic, C2. C2H5OH, ethanol. Here also there are 2 carbon. 1, 2. Ethanol. Ethane, C2H6. Ethene, C2H4. Eth means 2 carbon. Ethanol, ethanoic acid, ethene, ethine, ethanoic acid. Acetic acid. Or that is also called vinegar in the kitchen. So this is the most common acid present in our kitchen. Vinegar. Acetic acid. It's a weak acid. Partially ionized. Question number 3. Amphoteric oxide. Oxides can be classified into 4 types. What are the 4 types of oxide? Acidic oxide, basic oxide, neutral oxide, and amphoteric oxide. So this most of the chemistry question, most of the new syllabus recent oral past papers, they ask about this acidic oxides, the nature. If you don't know, write it quickly. I'll give you a summary of these 4 types of oxides. Okay. What are the 4 different types of oxide? Oxides can be classified into 4 types: acidic oxide, basic oxide, neutral oxide, and oxides. Oxide means when someone combines oxygen, we call it oxide. Number 1, acidic oxide. I'll write basic oxide. Some oxides are acidic. Some oxides are amphoteric. And 4th type, neutral oxides. Number 2, number 3, amphoteric. Number 4, neutral oxides. Basic oxide, this is short method. All the group 1 metal oxides are basic. All the group 1. Example, lithium oxide, basic. Group 1, sodium oxide, basic. Potassium oxide, basic. And group 2, magnesium oxide, basic. Calcium oxide, basic. Basic oxides react with acids as well as they react with water forming alkali or basic solution. Acidic oxides mostly by non-metallic oxides. Most of the non-metallic oxides are acidic. Example, consider about acid rain. Carbon dioxide is acidic oxide. That's why it dissolved in lime water. Lime water is basic. Carbon dioxide is acidic. It's like a neutralization reaction. Sulfur dioxide, acidic. Sulfur trioxide, acidic. Nitrogen dioxide, acidic. So these are acidic oxides. Even Cl2O7, halogens, all the oxides of halogens acidic. Amphoteric, so acidic oxides react with bases. Basic oxides react with acids. Amphoteric oxides react with both. Amphoteric oxides can react with acid as well as bases. Example, the most common amphoteric oxide, aluminium oxide. There are many other amphoteric oxide like zinc oxide, but in your syllabus, the most common amphoteric oxide is aluminium oxide. Even lead dioxide, lead PbO2 amphoteric. Now neutral oxide means what? They don't react with acids or bases or water. Neutral oxides, no reaction with nitric oxide, neutral. Nitrous oxide, neutral. Carbon monoxide, neutral. Neutral means they can be harmful. Example, carbon monoxide is toxic, but it's neutral. It doesn't react with water. It doesn't react with acids. It doesn't react with bases. Carbon monoxide, but it's a toxic gas. And nitrogen dioxide is a colored one. It's brown. Right? So most of the gases are actually acidic oxides are most of them are gaseous. These are solid. So these are the 4 different types of oxides. So if you want to write now, under each you can write here number 1 basic oxide, because sodium oxide if you put into water it forms sodium hydroxide. P2O5 it is acidic. If you put P2O5 into water it forms phosphoric acid H3PO4. Sodium oxide if you put into water it forms sodium hydroxide base. Aluminium oxide, surface of the cooking pot, so inner layer, it doesn't react with water. It doesn't react with water, but it reacts with acid and bases. That's why we should not prepare acidic and basic food in the aluminium pots, aluminium pans. Chlorine, this is highly acidic, non-metallic oxide. So therefore, across the period, acidity of the oxide increase. Down the group, basicity increase. So in the periodic table, when the electronegativity increases, acidity of the oxide increase, right? Okay, now we almost it's 12, so it's past midnight. Now you can get the recording also if any one of you with your name code, those who are coming for the regular online classes, those who are used to come may, and try to complete all the remaining questions of this. It will be a very good practice for you before the oral exam. This paper also, I think with today's with the knowledge that you gathered, you can definitely do it. Best thing to practice many questions possible rather than just reading the theory note. Then only it will definitely helps to will help to improve your marks. And so in some of the questions here I think Ms. Madhu discussed with you all. So with this then I will stop for today's seminar. So then you can watch the recording also if you want, and there are 2 other previous recording also available. Those who have already got the name code and added to the group, you can request that also. Biology seminar and physics seminar also, you can leisurely watch them and complete that paper also. Right, okay, then stop for today, and wish all very best for the upcoming oral exam, and I will definitely I hope you can hear from my students a good results after oral exam, and wish you all again very best, and good luck, and God bless you. Take care. And, if you have any doubt, you can ask through the WhatsApp even questions, no problem. I will help you until the end of your science paper. Right, okay then, take care, God bless you.